Hi everyone, welcome to Go Classes. Before we start, please let me know, is my audio clear? Am I audible? Let me know. So in this session, we are going to discuss All India Mock Test 2 solutions. This is part 3 of All India Mock Test 2 solutions. You can find part 1, part 2 in this playlist. So on the Go Classes YouTube channel, you can search Go Classes test quizzes. You can search. The link is in the description. You can check it out. Okay. So in the description, you can find the part 1 and part 2. So you can see All India Mock Test. So you can see this is All India Mock Test 2 solution part 1, and this is All India Mock Test 2 solution part 2. Okay. So the part 1, part 2 you can find here. Okay. Part 1 and 2. So in this playlist, basically you can find this playlist Go Classes test and quizzes and homework discussion. Okay. So in this playlist you can find the All India Mock Test 2 solutions. Similarly, in this playlist you can find All India Mock Test 1 solution also. Okay. So all the mock test solutions basically you can find in this playlist. You can check it out. The link is in the description. Okay. So let's start this part 3. Let me introduce myself. My name is Deepak Punia. I have completed my MTech from IISc, Indian Institute of Science, Bangalore. I have topped GATE exam many times. I have secured top rank in the GATE Computer Science multiple times. All India rank 53, All India rank 67, All India rank 107, 206, 256, etc. Okay. Also, if you want to attempt all Go Classes mock test, GATE Overflow plus Go Classes, all the 20 mock test if you want to attempt, then you can enroll for this mock test package. This mock test package you can enroll. So you can see GATE Overflow Go Classes full length mock test GATE. Okay, so this package, basically this package you can enroll, and in this package you will find all 20 mock test by GATE Overflow and Go Classes. Okay, so each and every mock test you can access here. So if you want to attempt all the 20 mock test of the GATE Overflow plus Go Classes test series, then you can enroll for this package. The link is in the description. You can enroll. You can also enroll for the complete test series. You can see GATE Overflow plus Go Classes. The complete test series also you can enroll. The link is in the description, or you can go to this link and you can enroll. In this test series, there are more than 100 tests and there are 20 mock tests. Okay, we have 20 mock tests in this test series. So you can enroll for this test series also, or you can enroll for this mock test package. Now, also let me tell you that on Go Classes website and app, the complete Discrete Mathematics course and complete Engineering Mathematics course, they are freely available for all the students. So complete Discrete Mathematics complete course, also Engineering Mathematics complete course. These are completely free for all the learners on the Go Classes website and app. So you can go to the Go Classes website, or you can download the Go Classes app from the Play Store or App Store. You can download Android app. You can also download iOS app. Okay, so search Go Classes on Play Store, App Store, and you download the Go Classes app, and you can easily access these lectures. Okay. So also you can join Go Classes Telegram group. So this is the username for the Go Classes Telegram group. You can join this Telegram group for doubt discussion. So you can see join Go Classes doubt discussion Telegram group. Okay. So the link you can find in the description, or what you can do, you can use this username. So this is the username for the Go Classes Telegram group. If you are a GATE 2025 or 2026 aspirant, then you can enroll for GATE Computer Science complete course. Okay, if you are GATE 2025 or 2026 aspirant, you can join Go Classes GATE Computer Science complete course. This complete course you can join. Okay, and remember, if you join now, then you will get 1 or 2 months of extra validity. Okay, so if you join now, then extra validity you will get. Basically, your course will expire after the GATE 2025 exam. If you are enrolling for 1 year, if you are enrolling for GATE 2025, if you enroll today, then you will get 1 or 2 months of extra validity. Okay, similarly, if you enroll for 2026, then also you will get 1 or 2 months of extra validity you will get. So you can start your preparation right now. If you are a GATE 2025 or 2026 aspirant, you can start your preparation immediately without wasting any time. You can join goclasses complete course, goclasses computer science complete course. Also, if you are GATE DA student, if you want to prepare for GATE data science and artificial intelligence, then you can join this GATE DA complete course. You can join. Okay, so you can see the validity will be for 1 year plus 2 months. Okay, so 2 months of extra validity you will get, 1 year plus 2 months extra validity you will get. So if you are a GATE DA aspirant, then you can join this GATE DA complete course. You can join. Okay, the link is in the description. You can check it out. Okay, now let's come back to All India Mock Test 2 solutions. So this is All India Mock Test 2 solutions part 3. Okay, so let's start. So let's start with this question. In this question, a figure is given to you. The figure above shows an undirected graph with 6 vertices. This is the undirected graph. There are total 6 vertices, and you can see there are total 9 edges. Enough edges are to be deleted from this graph. We have to delete some edges are to be deleted from this graph in order to leave a spanning tree. What is a spanning tree? It is also given to you in this question. The spanning tree is basically a connected subgraph which has 6 vertices, same 6 vertices, and there is no cycle. Okay, so remember what is a spanning tree? In this question, the question is saying that undirected graph is given to you. There are total 6 vertices, there are total 9 edges. So you can see total we have 6 vertices. And if you calculate, there are total 9 edges. Okay, and the question is saying that we have to delete some edges. Enough edges must be deleted so that finally what we should get? We should get a connected subgraph. This is the result we should get. We should get a connected subgraph which has same 6 vertices. You cannot delete a vertex. Is this clear? You cannot delete a vertex. So remember, you must get a connected subgraph. Okay, with the same vertices, with same 6 vertices. So you cannot delete any vertex. We cannot delete any vertex. Okay, with same 6 vertices and no cycle. No cycle. Okay, so we have to delete only edges. So how many edges must be deleted? How many edges must be deleted so that we get a connected graph with no cycle and you cannot delete any vertex? So tell me, how many edges you must delete? So very simple point. Basically, from this graph, you delete some edges such that you get a tree, right? Yes or no? Connected, no cycle. What that means? If I tell you these two words, connected plus no cycle, this simply means a tree, right? Yes or no? If you have a connected graph which has no cycle, then this is the definition of tree. This is the definition of a tree. Okay, so the question is saying that you have 6 vertices and you cannot delete any vertex. So you tell me, if you have a 6 vertices tree, then how many edges you must have? 6 vertices tree. Tell me, 6 vertices tree will have how many edges? Very simple. It will have total 6 minus 1. That is 5 edges. Yes or no? If you have total n vertices tree, if there is a n vertices tree, then that will have how many edges? That will have n minus 1 edges. So you can see, if you have 6 vertices tree, then that will have total 5 edges. So ultimately, you should only have 5 edges. The remaining edges must be 5. Okay, if you are creating a spanning tree, basically if you are creating a tree from this, then you must, remaining edges must be 5. Is this clear? So remember, you must have 6 vertices and 5 edges. So how many edges you must delete? That is 9 minus 5. That is 4. Okay, so how many edges must be deleted? That is 9 minus 5. That is 4 edges must be deleted. Okay, so very simple question, right? Yes or no? So this is quite a question. This is quite a simple question, a straightforward question. Okay, this concept of spanning tree you also study in the data structure and algorithm, right? Yes or no? What is a spanning tree? How to find minimum cost spanning tree? So basically this concept of spanning tree you also study in the data structure and algorithm subject. Okay, but this is a very simple question. A graph is given to you, and from this graph basically some edges you have to delete so that you get a tree. Okay, so that you get a tree, because connected no cycle, that simply means that is the definition of a tree. And remember, if you have n vertices tree, then that will have n minus 1 edges. So basically, you delete some edges such that the remaining edges are 5. The remaining edges are 5. So how many edges you need to delete? That is 9 minus 5, that is 4. 4 edges you must delete so that you can get a spanning tree. Okay, so very simple question. Now let's solve this question. This is another simple question, but in this question some students they have made silly mistake. Okay, so let's read this question. Let a minus b denote elements which belong to a which do not belong to b. Okay, so this is the definition of a minus b. Basically, in a minus b we have those elements which belong to a but they do not belong to b. Okay, x belongs to a such that x does not belong to b. So these elements we have in this a minus b. If a minus b union b is equal to a, then which of the following must be true? The question is asking which of the following must be true. So 4 options are given to you, which must be true. Okay, so let's see. First of all, a minus b definition is given to you. What is a minus b? A minus b is basically those elements which belong to a such that they do not belong to b. Okay, so let's see the Venn diagram. If this is your set A, if this is your set B, then you can easily see A minus B is this area. Those elements which belong to A but do not belong to B. So this is the area A minus B, right? Okay, we have those elements which belong to A, they do not belong to B. So this is your area of A minus B. Now the question is asking that if this is given to you, A minus B union B is equal to A. The question is saying that this is given to you, A minus B union B is equal to A. Then what should happen? Then what must happen? See, very simple point. This is your A, this is your B, and what you are saying? You are saying that this A minus B union B is equal to A. See, notice one thing. Notice one thing. This is A minus B. Please notice. This is A minus B, right? Yes or no? This is A minus B. And union B. What is B? This is B. This is B, right? Yes or no? Okay. So you tell me one thing. What is A minus B union B? From this Venn diagram you notice, because this green area is the A minus B and this orange area, that is basically B. Now if you take their union, what you should get? You should get A union B, right? Do you agree with me? You should get A union B. This is what you should get, A union B. And the question is saying that A union B equal to A. The question is saying that A union B is equal to A. This is given to you in the question. In the question, this is given to you that A union B that is equal to A. This is given. Now the question is asking what must be true for B. The question is asking what must be true for B. So remember what is given in the question? What is given in the question? In the question it is given that A union B is equal to A. This is given, A union B equal to A. So what that means? Remember, this will happen if and only if. This will happen if and only if B is a subset of A. This will happen if and only if B is subset of A. So remember, if this happens, then B will be subset of A. And if B is subset of A, then this will happen, right? Yes or no? This is a very simple point. So you can easily see A union B that is equal to A. This can happen only if and only if B is a subset of A. In this situation, what will happen? In this situation, you can notice that A union B will be equal to A. And remember, this is the only situation in which A union B will be equal to A. So please understand, this is a if and only if. Please notice, this is a if and only if condition. This is two-way condition. Means if B is subset of A, then A union B will be equal to A. And if A union B equal to A, then B will be subset of A. So this is if and only if condition. What it means? It means that this must be true. B is subset of A, that must be true. Okay, so the question is asking what must be true. The question is asking what must be true. So you can see B is subset of A, that must be true. The answer will be option C. Now, what about option B? What about option A? See, if B is empty, then also this will happen, right? Yes or no? But this is not necessary. The question is asking necessary. The question is asking what must be true. What must be true? The question is asking which option is necessary to be true. So you can see option B, that is possible but not necessary, right? Yes or no? See, B is empty, that is possible but not mandatory. But not mandatory. Do you agree? So this is where many students have made mistake. Basically, in this, remember, many students, they have made mistake. So you can easily see that B is empty. That is not mandatory. That is not mandatory. See, if B is empty, then this condition will happen. But if this condition happens, then can I say B will be empty? Please notice what I am saying. Let's look at option A. Option A is saying B empty. Option A is saying B empty. Please understand one thing, that if B is empty, then definitely this will happen. What will happen? Then definitely this A minus B union B will be equal to A. Okay, then definitely this will happen. I agree. Okay, but remember, the question is asking, if this happens, then what will happen? If this happens, then this may not be happen, right? So please understand what the question is asking. Okay, did you understand? The question is saying, if this happens, then what will happen? You tell me, if this happens, then what will happen? Okay, so I hope you got this point. And what this means? This simply means A union B equal to A. Okay, we have already seen. So please remember that if B empty, what the question is asking, please focus on that. What the question is asking. The question is asking, focus on what the question is asking. The question is asking that if A union B equal to A, then what must be true? Okay, then what must be true? Then what must be true? Yes or no? Okay, so please understand. Now you tell me, if this happens, then can I say B must be empty? No, because for example, you can take this example, like you can take A set of integers, you can take B set of natural numbers. Now here you can easily see that A union B will be equal to A. Okay, so remember, definitely I can say option B is possible but not mandatory. Yes or no? So the question is asking must be true. So this is not correct. Similarly, what about option A? What about option A? That is also not correct. Okay, and similarly you can check this option D. What the option D is saying? B minus A union A equal to B. Okay, see, B minus A union A equal to B. This option is basically saying that A union B equal to B. Okay, this option is same as A union B equal to B. A union B equal to B. Okay, this is what this option is saying, right? Now you can easily see this also may not be true. Okay, yes or no? This also need not be true. So because you can consider this example, the same example you can consider like this, that A is integers, B is natural numbers. Then you can see A union B is equal to A, but you can notice A union B is not equal to B. Okay, is this clear? Please tell me. Let me know. Is this question clear to everyone? Anyone has any doubt in this? Okay, so very simple question, right? Yes or no? So remember, this is given to you. What this is saying? This is saying A union B equal to B. A union B equal to A. This is what the question is saying. Now let me tell you one thing, that option A implies this, but the question is asking if this happens, then what will happen? The question is asking if this happens, then what will happen? So remember, this must be true. Okay, I can say that option C. I can say that this A union B equal to A. This implies option C. This implies option C. Also option C implies this. Also option C implies this, right? This is the one thing. You can see option A implies this, but this does not imply option A, right? You can easily notice that this does not imply option A. This does not imply option A, but remember option A implies this. But remember option A implies this, right? Yes or no? So I can say option A definitely implies this. Okay, so I hope you understood. What about option B? Can I say, what about option B? Tell me. Can I say option B will imply this? Let me know. Let me know. Can I say option B will imply this? See what I am saying, that this is the given statement given in the question A union B equal to A. And you tell me what about option B? Option B is saying that A union B equal to, sorry, A is subset of B. Option B is saying A is subset of B. A is a subset of B. Now you tell me, does it imply A union B equal to A? Please tell me. Does it imply A union B equal to A? This does not imply, right? Yes or no? Also, A union B equal to A, does it imply that A is subset of B? That A is subset of B? That also does not imply. So option B is definitely not correct. Whatever side you take, yes or no? You can take any side you can take. So both the sides, option B is not correct. What about option D? What about option D? Option D is saying that B union A equal to B. Okay, yes or no? Option D. Option D is saying that B union A is equal to B. This is what option D is saying. Option D is saying that A union B is equal to B. Okay, remember again, this does not imply A union B equal to A. Also, this also does not imply this. So please understand, this is also, both sides, this is also wrong. Is this clear? Tejas is asking option D doubt. Okay, let's focus on option D. What this option D is saying? Look at option D. Option D is saying B minus A union A is equal to B. Let's create the Venn diagram. Let's create the Venn diagram. This is A. This is B. Tell me, what is B minus A area? Let me know what is B minus A area. This area is B minus A area. Please notice. This area, this is B minus A area. Now you tell me, what is union A? Union A. This area is A. This area is A. So union A. Union A. Now tell me, what will be the result? The result is A union B. The result is A union B. Yes or no? So this is nothing but A union B. Agree with me? This is nothing but A union B. And this is equal to B. Yes or no? This is option. This is what your option D is saying. So please notice what option D is saying. Option D, you can rewrite option D like this. This option D you can rewrite. What you can say? You can say basically A union B equal to B. This is what your option D is saying. Is this clear, Tejas? Let me know. Please tell me. Is your doubt clear? Okay. So let's move on now. Let's solve this question. This is another simple question from the ER model in DBMS. You can see, given the portion of an ER diagram shown above, this ER diagram is given to you with thick arrow from R to A. This thick arrow is given to you, bold arrow is given to you. Which of the following statement are true? So first of all, look at this ER model and what this ER model is. Okay, look at this. The question is saying that there is entity A, this is entity set A, and there is entity set B, this is entity set B, and there is a relationship between them. There is a relationship R between them. You have relationship R. And the participation, also the cardinality, mapping cardinality. Let's look at the participation and the mapping cardinality. You can see this is given to you something like this, that there is a thick line here. Okay. And this arrow is given to you. Right? Yes or no? So first you tell me, let's look at the participation. So this thick line, this means total participation, right? Yes or no? This thick line, okay, this thick line indicates total participation. So remember, this entity set, this has entity set A, it has total participation in relationship R. Okay, so remember, thick line indicates total participation of in relation R. Very simple. Okay, so remember, this entity set A, this has total participation in this relationship R. Okay, but this entity set B, this has partial participation. Okay, here you have partial participation in the relationship. Yes or no? So there is a partial participation. Okay, so this is the simple point. Now let me tell you, this total participation, either you can indicate by a thick line or you can indicate by a double line. Okay, so remember, please let's see the notation. Let's see the notation for total participation. Okay, let's see the notation for total participation. So there are two notations for total participation. The first notation is basically double line. Either you can use a double line, like for example, if this entity set A, this has total participation in this relationship R, then what you can do, you can put double line. Okay, double line indicates basically total participation, or you can indicate by a thick line. Okay, so what you can do, you can indicate by a thick line. Okay, you can put a thick line here. Okay, so the notation for total participation. What is the total participation notation? That is either double line, or thick line. Okay, so I hope you got it. So very simple point. Remember, you can see here the total participation notation that is indicated by double line or thick line. Okay, either a double line or a thick line. So very simple point. So you can see here that you can indicate the total participation by a thick line. So if you have a thick line, that means total participation. This is total participation. This is partial participation, right? Yes or no? So you can see, look at this ER model, this ER diagram here. This manages, this is the relationship. This employee entity set, this has partial participation in this relationship, but this department entity set, this has total participation in this manages relationship. Okay, very simple point. So this is how you can indicate the total participation. I hope you understood. So here what is happening? Here this has total participation, right? So you can see there is a total participation here. There is a total participation here. Also, what is given to you? Also, you can easily see that this is see, this arrow indicates what this arrow indicates. This indicates one, right? One to many. So this is one to many because this arrow indicates one. Okay, so you can easily see that this is A. Okay, this is your relationship R, and this is the entity set B. Now this arrow indicates one. Okay, this arrow indicates one. What that means? This is one to many relationship. Okay, this is one to many relationship from A to B. This is one to many relationship from A to B. Okay, with total participation of A and partial participation of B. Yes or no? So remember this relationship, if you notice, this is like this. That if you have some like A1, A2, A3, A4, if you have these here, and let's assume in B you have B1, B2, B3, B4, B5, B6. Okay, then in this situation you can see A has total participation, and this relationship, if you notice, between entity set A and entity set B, this relationship is one to many from A to B. This is one to many from A to B. What it means? This is one to many from A to B. Okay, so this type of relationship this is. Also, total participation of A means every entity of A must be related to at least one. Yes or no? Very simple point. Okay, so you can easily see. And remember, this is many to one from B to A. Okay, this relationship, this is many to one from B to A. Many to one from B to A. Yes or no? So you cannot have this. This type of thing you cannot have. Please understand. Please understand, this is not allowed. Why this is not allowed? Because you can see, basically this is not allowed. Why this is not allowed? Because this is many to one from B to A. This is B, this is A. So from B to A, this is many to one. Okay, so you can see, if you take any entity of B, that will be related to at most one entity of A, because there is partial participation of B. So remember, finally I can say this type of diagram is possible. Okay, you can see this type of diagram is possible. Now you can easily see there is partial participation of B. So this entity of B, this is not related to anyone. Look at this entity of B. This is not related to anyone in A. Yes or no? There is total participation of A. You can see every entity of A that is related to at least one entity of B. There is one to many mapping. This relationship, this is one to many from A to B. So you can easily see this entity, this can be related to more than one entity in the B side. But on the B side, any entity will be related to at most one entity on the A side, because from B to A, this is many to one. Okay, I hope you clearly understood what is this given ER model, what this given ER diagram means. Yes or no? So let's see which statement must be true. Which statement are true? R connects each entity in A to at least one entity in B. Yes, that is correct. Yes or no? That is correct. R connects each entity in A to at least one entity in B. This is correct. This is true because of total participation, right? Yes or no? This is correct because of total participation of A. There is total participation of A. So this statement is correct, that R connects each entity of A to at least one entity in B. This statement is correct. R connects each entity of A to at most one entity in B. This statement is not correct because there is one to many from A to B. From A to B, there is one to many. So remember, if you have some entity here, then that entity can be connected to more than one entity in B side. Very simple. R connects each entity of B to at least one entity of A. This is wrong because there is partial participation of B. Yes or no? So it is possible that some entity of B is not related to any entity of A. Next, R connects each entity of B to at most one entity in A. This statement is correct because there is many to one mapping from B to A here. You can see. Also, there is partial participation of B. So finally, you can see 1, 4th. These are correct. Answer will be option C. Okay, answer is going to be option C. The question is asking which statement is true. Answer will be option C. Okay, so quite easy question. Just give me 1 second. Hello, am I audible? Please let me know. Hi everyone, am I audible? Please tell me. So did you understand this ER model question? Let me know. This was again very simple question, straightforward question. You just have to analyze the given ER diagram and you can easily see option 1, option 4th. These are correct. Okay, so did you understand this ER model question? Let me know. Is this question clear? ER diagram question. Okay, let's move on now. Now let's solve this question. This is another beautiful question from pipeline in computer organization and architecture. This is a beautiful question. The question is saying which kind of data dependence can cause data hazard. Okay, see, the question is saying which kind of data dependence can cause data hazard in single core pipelined in order processor. Okay, the question is saying there is a single core processor, you don't have multi-core processor. So basically single core processor, that simply means single issue, single core, or you can easily call it single issue. Okay, so single core processor you have, pipelined in order processor. Okay, so in this processor, if you have an in order processor, then which of the data dependence can cause data hazard? So the answer is only read after write dependence. Okay, they cannot cause data hazard in order pipeline. The video solution for this question is already available. I have provided to you. Okay, so you can watch it here. Detailed video solution I have already provided. You can check it out. Okay, so just go to this question. In the explanation, I have already provided a detailed video solution. Also, I have provided the proof. Notice. I have provided the proof that WAW and WAR hazard are never possible in in-order pipeline. Okay, so you might be thinking, what is in-order pipeline? That is also explained here. In this video, just go to this video. I have explained what is in-order pipeline. Okay, what in-order pipeline means. What is the in-order pipeline? In this pipeline, in in-order pipeline, you can easily see that WAR and WAW hazards are never possible. They are never possible. And this proof I have given to you in this video. Okay, so you can just check it out. This question, this is a beautiful question, let me tell you, from a standard university. Okay, I think this question is taken from, I think, Virginia Tech University. Okay, so this is a beautiful question. Okay, I hope you, so you can just watch the video solution and you can learn something new. Okay, so this is quite a beautiful question. Okay, now the complete pipeline playlist is also available on the goclasses YouTube channel. If you want to study the complete pipeline, remember, goclasses pipeline complete playlist, the complete pipeline course, that is already available on the goclasses YouTube channel. You can see pipeline complete playlist, hazards in pipeline, everything is given in these lectures. You can see everything is given. You can see hazards, what is data dependence versus data hazards. Yes or no? Row dependency versus RAW dependency versus RAW hazards, WAW dependency versus WAW hazards. That is also given to you. Okay, control hazards, their solution, data hazards, their solution. So everything is covered in this playlist. Okay, so if you want to study pipeline in a depth way, okay, in a correct way, if you want to understand every concept in a crystal clear way, then you can watch this playlist. Okay, so this is the Go classes pipeline complete playlist. You can check it out. Okay. Now, so for this question, the video solution is already available, so you can check it. Okay, let's move on to the next question. Let's solve this question. Okay, so this is another question from computer organization, and this is very simple question from pipeline. So what this question is saying, an MIPS pipeline has 5 stages with a clock cycle of 200 picosecond. Suppose that MIPS pipeline is redesigned to have 4 stages with a clock cycle of 250 picosecond. Assume that infinite sequence of instructions are there. Assume an infinite sequence of instructions. What speed up the new design achieve when you compare it to the old design? Okay, so the question is very simple. Basically, there is a old design. Okay, so you have, I can say there is a old design. In this old design, what we have? In this old design, we have, there are total 5 stages and clock cycle is given to you, that is 200 picosecond, right? Yes or no? So there are total 5 stages. In this old design, there are total 5 stages. You have a 5 stage pipeline where the clock cycle time, basically, that is given to you 200 picosecond. Okay, so I can say cycle time, that is 200 picosecond. Okay, so in this, you tell me if there are n instructions, then what will be the execution time? Tell me what will be the execution time if you have n instructions. Execution time for n instructions. If there are total n instructions, then what will be the execution time? Let me know. Please tell me. Execution time, if you have total n instructions, there are total n instructions. So you can easily see this is a pipeline. Okay. In this pipeline, what will happen? The first instruction will go through all the stages, right? Yes or no? Actually, every instruction will go through all the stages, but the first instruction will basically take five cycles. Yes or no? If you look at the first instruction will take 5 cycles to complete, because the first instruction will go through all the stages and it will take 5 cycles to complete. So 5 cycles for the first instruction. These are for first instruction. Okay. Now you can notice when the first instruction is here, then the second instruction is here. Now you can see when first instruction will complete, then this second instruction will take only 1 cycle to complete, right? Yes or no? So you can see the first instruction will take 5 cycles to complete, 5 cycles for the first instruction, but the remaining instructions, all these remaining instructions, they will take only 1 cycle, because you can see when I1 is in the last stage, in the 5th stage, then I2 will be in the 4th stage, I3 will be in the 3rd stage, I2 will be in the 2nd stage, and I1 will be in the 1st stage. So you can see, this, I can say I4 will be in the 2nd stage and I5 will be in the 1st stage. Now you can see the first instruction will take total 5 clock cycles to complete, and after that in every cycle 1 instruction will be completed. Yes or no? After that, these instructions, the remaining instructions, they will take 1 cycle each. Okay, so finally I can say the execution time will be basically these many cycles, and 1 cycle time that is given to you, that is 200 picosecond. Yes or no? That is the cycle time that is given to you. So finally I can say execution time will be 5 plus n minus 1, this whole thing multiplied by 200 picosecond. This will be the execution time for the old design. What about the new design? In the new design, what we are doing that you have 4 stages. In the new design, there are total 4 stages and cycle time is 250 picosecond. This is the new design. So in this new design, you tell me if there are total n instructions, then what will be the execution time? If you have n instructions, then execution time will be what? Execution time for total n instructions. If you have total n instructions in your program, then what will be the execution time? Very simple. Again, you have 4 stages. So the first instruction will go through every stage. So this is for first instruction. First instruction will take 4 cycles to complete. But after that, in every cycle, one instruction will be completed. Yes or no? After that, the remaining instructions, they will take 1 cycle each. Okay, in every cycle, one instruction will be completed. So you can easily see this is going to be the execution times. These many cycles, and the cycle time is given to you, that is 250 picoseconds. So I can say here you have 4 plus n minus 1, these many multiplied by 250 picosecond. This will be the execution time. Okay, this is the execution time. Very simple. Now the question is asking speed up of new design comparing to old design. Yes or no? Now let me tell you something. If you want speed up of system A, comparing to system B, then what is the formula? Then what you will do? If you want speed up of system A, remember what you want? You want speed up of system A. This is what you want. You want a speed up of system A comparing to system B. Then in this situation, what you will do? Very simple. Execution time of A, that will come in bottom. That will come in denominator. So execution time of A, basically execution time of B divided by execution time of A. Execution time of B divided by execution time of A. Yes or no? This is the expression for speed up of system A. You are counting speed up of system A comparing to speed up of system B. I can say, speed up of system A you want to calculate comparing to the system B. So that will be execution time of B divided by execution time of A. Okay. Now in this question, the question is asking the speed up of new design. Speed up of new design. What speed up this new design will achieve when you compare it to the old design? So tell me, what will be the speed up of new design? Let's see the speed up of new design. Speed up of new design. Okay, this is what you want. You want speed up of new design comparing to the old design. Yes or no? Comparing to old design. If you compare it to old design, then what is the speed up of new design? So the formula is very simple. The execution time of new design, that will come in denominator. Yes or no? So execution time of new design, that will come in denominator. And execution time of old design, that will come in numerator. Okay. So now here you can easily see this is what you will do. Now if you have total n instructions, then what will happen? If you have total n instructions, then execution time of old design, what is that? Execution time of old design, that you can easily see here. Execution time of old design. So let's see, that is 5 plus n minus 1, that is n plus 4 into 200. Yes or no? So that is n plus 4 into 200 picosecond divided by execution time of new design. That is what? Execution time of new design, that is n plus 3 multiplied by 250 picosecond. This will happen if you have total n instructions. So remember, this will happen for n instructions. If you have total n instructions, then this will be the speed up, right? Yes or no? But the question is saying you have infinite number of instructions. You have infinite sequence of instructions. And because you have infinite sequence of instructions, so now what will happen? If n is infinity, okay, here what to do? If you put n equal to infinity, then basically these you can cancel. Okay, these you can cancel because n is very big. See, if n is very big, you notice if n is very big, if n goes towards infinity, then what will happen? Then this n plus any constant, yes or no, n plus constant, that will be n. Yes or no? So you can see if n is very big, n is a very big number, it is going, I can say it tends to infinity. This simply means n is a very big number. In this situation, n plus constant, that is basically same as n. So you can cancel these. So you will finally get 200 divided by 250. And if you calculate this, this will be 0.8. Okay, this will be the speed up of new design when you compare it to old design. So the answer will be 0.8. For this question, the answer is going to be 0.8. Is this clear? The answer will be 0.8. Now let me tell you what is the mistake many students did. many students, they did this mistake that they took the execution time of old design on top, and sorry, new design, execution time of new design on top, and execution time of old design on the denominator. This is what many students did, and they got 1.25. But this is wrong. Why this is wrong? This answer, this speed up is wrong. This is wrong. Why this is wrong? Because the question is asking speed up of new design comparing to old design. So please understand what the question is asking. Okay, remember the question is asking. Remember the question is asking the speed up of new design. The question is asking speed up of new design comparing to the old design. When you compare to old design, comparing to old design. Okay, so this is the point. The question is asking the speed up of new design, and the new design is actually slow. The new design is actually slow. That is the reason the speed up is 0.8. That simply means new design is slow. Because your speed up is less than 1. Yes or no? Your speed up, that is less than 1. So that simply means that new design is actually slow. The old design was actually better. The new design is actually slow. Okay, the old design was faster. The new design is slower. So that is the reason speed up is less than 1. When the speed up is less than 1, that simply means new design is slow and the old design, that is fast. So I hope you understood this. Anyone has any doubt? Let me know. Please tell me. Anyone has any doubt? Please tell me. In this question. So did you make this mistake? Did you make this mistake that did you put 1.25 in the answer? Let me know. So don't make this mistake, because the question is clearly telling you what you need to calculate. You need to calculate what is the speed up of new design when you compare it to the old design. So this is what the question is asking. So the answer will be 0.8, not 1.25. Okay. So let's move on now. Let's solve this question from digital logic. This is a very simple question. Which of the following option is correct for the given circuit? A circuit is given to you. The question is asking which of the following option is correct. So this is a very simple combinational circuit. You can see some logic gates are used. This is OR gate, AND gate, NAND gate. So these are given to you. Now let's find out what is X. So what is X? First you calculate what is X. So you can see here, this is basically PQ. Okay, because this is a AND gate. So this is a AND gate. So this will be PQ. This is a NAND gate. This is a NAND gate. And for this NAND gate, both the inputs are P. So what will be this? What will be this output? This output is going to be P bar. Yes or no? This output is going to be P bar. And finally, there is a OR gate here. So what will be X? X will be basically P bar or PQ. X will be P bar or PQ. And you can simplify this. You can apply the distributive property. You can simplify this and you will get P bar or Q. Basically, this is a property, let me tell you. You can remember this property. This is very important property. X or X bar Y. Okay, if you have X or X bar Y, then if you have this type of situation, X or X bar Y, then you can cancel this X bar. What you can do? X or X bar Y, this X bar you can cancel. Okay, so you can just simply say X or Y. Similarly, if you have, for example, X bar or XY, then also the same thing, because this is the complement. Okay, so what you can do here? Here you can cancel this and you will get X bar or Y. So the same thing you can do here. So this is your X. This is finally your X. Now let's see the options. Which option is correct? X is equal to P bar or Q. Remember, X must be equal to P bar or Q. So now you tell me which option is correct. X must be P bar or Q. So you can see P bar or Q. No, this is wrong, because here P bar or Q, that should be 1. Means here X should be 1. What about this P bar or Q? Here X should be 0. Okay, here actually X should be 0. Yes or no? Next, P0, Q1. Here actually X should be 1. Finally, yes, option D is correct. When P0, Q0, then X will be 1. Yes, this is correct. Okay, so answer is option D. This is a very simple question from digital logic. Straightforward question. So far, all the questions were easy, right? Please tell me. So far, all these questions, these are very easy, straightforward questions. Because I am explaining, so these questions are taking time. Because I am explaining to you. But if you are solving these questions, these are very easy questions, right? Yes or no? Is this clear? Please tell me. So did you find these questions easy or not? Let me know. So all these questions so far, these are very easy question. Okay, let's move on. Let's solve this question. Consider the bit pattern. This bit pattern is given to you 1011 0110. Interpret this bit pattern as 8-bit 2's complement number. This is a 8-bit 2's complement number. What is the largest magnitude negative number that can be added to this value without causing 2's complement overflow? Okay, what the question is asking? See, a number is given to you and the question is asking what is the largest magnitude? What is the largest magnitude negative number that you can add to this number without causing any overflow? See, what is overflow? When overflow will happen, let me know. Whatever number system you take, okay, if you have some XYZ number system, let's assume you have some XYZ number system. It does not matter what is your number system. If you have some XYZ number system, and in this number system, if you, let's assume if you add two numbers A comma B, if you are adding these two numbers, then tell me when the overflow will happen. When you do A plus B, then in which situation the overflow will happen? Just tell me the definition of overflow. So when you do A plus B, then overflow happens. Overflow happens if and only if this A plus B, basically the result, the correct result, okay, the overflow will happen if the correct result of A plus B, when you add them, then the correct result cannot be stored in n bits. Okay, cannot be stored in n bits. So remember, overflow will happen. This overflow is going to happen if the correct result when you add A plus B, then the correct result cannot be stored in the given n bits. Is this clear? Very simple point. I hope you understood this point. So whatever number system you take, it does not matter. The same idea you can apply. Basically, when you do A plus B, then the overflow will happen if the correct result, when you do this A plus B, then the correct result cannot be stored in the given n bits. Okay. Now the question is saying that this number is given to you in the 2's complement. Okay, 1011 0110. This number is given to you in the 2's complement number system, and this is 8-bit 2's complement number. This is basically 8-bit 2's complement number. Yes or no? 8-bit 2's complement number. So if this is 8-bit 2's complement number, you tell me what is this number, let me know. What is this number? First of all, you tell me what is this number. In the decimal, what is this number? Let's calculate in the decimal what is this number. You can see in the decimal, this has the negative weight. Okay, 2's complement, when you convert 2's complement number into decimal, then you can see this MSB, this always has negative weight. So it will be like minus 2 power 7 plus, this will have positive weight. So it is basically 2 power 5. Okay, plus this will basically be 2 power 4 and plus this will be basically 6, right? Yes or no? So what you got? You got minus 28 plus 32 plus 16 plus 6. Can you tell me what is this value? What is this value? Let me know. I think this value will be minus 74. You can check it out. What is this value? Okay, you can calculate what is this value. So you can see this is the given number. This is the given number. The given number is minus 74. Now the question is saying that this is 2's complement. In this given number, in this minus 74, what is the value you can add? What is the maximum negative number you can add? The question is saying that you add a negative number and m is the magnitude. M is the magnitude. The question is saying that this should be largest magnitude negative number. Okay, remember this should be largest magnitude negative number. This must be largest magnitude. This must be largest magnitude negative number. Which you can add such that no overflow occurs. Remember, this must be largest magnitude negative number which you can add to the given number such that no overflow occurs. Okay, no overflow should occur. No overflow should happen. Is this clear? Very simple. The question is saying you should not have 2's complement overflow. Okay, so you tell me in the 2's complement what is the range? If you have 8 bits, tell me if you have 2's complement number. In the 2's complement number system, in this number system, 2's complement number system, okay, so in this 2's complement number system, if you have total n bits, then what are the range? Which numbers you can represent in 2's complement number system using n bits? So in n bits, you can represent minus 2 power n minus 1 to 2 power n minus 1 minus 1. These many numbers, this is the range. Yes or no? This is the range which you can represent. These numbers you can represent in n bits in the 2's complement number system. So if you have total 8 bits, then you can represent minus 2 power 7 to 2 power 7 minus 1. That is simply minus 28 to 27 plus 27. Yes or no? Plus 127. So you can see minus 128 to plus 127. These numbers you can represent in 8 bits in the 2's complement number system. Okay. Now, when the overflow will happen? Overflow will happen. See, minus 74. This is your minus 74. So tell me, overflow will happen. Okay, the largest number. This is the largest number. This is the largest negative number you can add such that overflow should not happen. Remember, overflow must not happen. Overflow should not happen. And because this is largest, so in worst case, basically you can go till minus 28. Yes or no? You can go till minus 28. Agree or not? You can go till minus 28. Okay. So this number you can add such that you will go till minus 128. So from here, what will be the value of m? You can calculate the value of m, that will be minus, or I can say the value of minus m. What is going to be the value of minus m? That will be minus 128 plus 74. Okay. So you can just calculate this. This will be total 4, 5. Yes or no? This will be minus 54. Okay, is this clear? So minus 54, this is the largest magnitude negative number you can add such that no overflow will happen. So remember, for this question, what you can do, this is the given number. Please understand, the given number is minus 74. The given number is minus 74. And in this minus 74, the largest number that you can add, the largest negative number that you can add, largest magnitude negative number. Notice here, largest magnitude negative number. So this is the largest magnitude negative number you can add such that there will be no overflow. The correct result will be minus 128. So there is no overflow. There is no overflow. Yes or no? There is no overflow. So the question is asking, write your answer in decimal. Only the magnitude you have to write, not the sign. So you have to write only the magnitude. So the answer will be 54. Okay. You can say the answer will be 54. So this is a very simple question. I hope you understood. Please tell me, did you understand this? This question, did you understand? Let me know. So this is a very simple question. Basically, the given number is minus 74. And in the given number, you have to add largest magnitude negative number such that you should not get any overflow. So the largest magnitude negative number that you can add to the given number, that is minus 54. The question is asking, write the decimal value, only the magnitude we have to write. So the answer will be 54. Okay, is this clear? Now tell me one thing, in this question, if this last line is not given, okay, if they say this line is not given, then what will be the answer? If they say that this line is not given, let's assume this line is not given, now the answer will be minus 54. Okay, now the answer will be minus 54. Is this clear? Because this is the largest magnitude negative number. This minus 54, this is the largest magnitude negative number that you can add to the given number such that no overflow will happen. Okay, so please understand, this is the largest magnitude negative number. So your answer will be minus 54 if these words are not given. If this line is not given. Okay. Let's move on now. Now let's solve this question. So far every question is clear. Let me know. Okay, let's see the next. Let's solve this question. A function is defined in this question, and the question is asking what is the value of f23. Okay, let's solve it. So the definition of function is given to you. F is a function such that for all positive integers x and y are positive integers, that means natural numbers 1, 2, 3, 4 and so on. So x comma y, they can take values from positive integers, and the question is saying fx comma 1, that is x plus 1, f1 comma y, that is 2y, and fx plus 1 y plus 1, that is equal to f of fx y plus 1 y. Then what is f23? Okay, so this is the function that is given to you. Now let's solve this question. Let me tell you the best way to solve this question. See, the question is actually very simple. The question is saying that fx comma 1, that is x plus 1. The question is saying that f1 comma y, that is 2y. Okay, now the question is asking what is f23, but the question is also saying that f of x plus 1 y plus 1, f of x plus 1 y plus 1, that is f of f x y plus 1 y. Okay, so this is the question that is given to you. Now let's solve this question. Okay, this question you can solve by two ways. Let me tell you the method number 1, which many students will use, but the method number 2, that is more efficient. See, this is the question, and the question is asking what is f23. This is what the question is asking. So let me tell you the method number 1. The method number 1, actually this method is actually inefficient. This method number 1, this is a slow method. Okay, but this is the method that will come to your mind very naturally. Okay, this method number 1 will come to your mind very naturally, it will come to your mind. So let's see this method number 1 first. You can easily see the question is asking f2 comma 3, yes or no. And f2 comma 3, how can you find it? See, fx comma 1, that is x plus 1, but the question is asking f23, so you don't have 1 here. Similarly, f1y, that is 2y, but you don't have 1 here. So you can use this equation. This equation we can use. Fx plus 1 y plus 1 is equal to f of fx y plus 1 comma y. Yes or no? So basically this you can write like this. F of 1 plus 1, 2 plus 1, right? Yes or no? Now you can use this expression. Fx plus 1 y plus 1 is equal to f of fx y plus 1 comma y. So what you can do? You can say f of fx comma y plus 1, okay, comma y. So this is what you can write it. Yes or no? This is what you can write it. I hope you understood. So very simple. Is this clear? Now tell me what is f13? What is f13? What is that value? Is this clear? See, what is f23? If you want to find what is f23, let me just quickly tell you. This is given to you that f of x plus 1 y plus 1, that is equal to f of x plus 1 y plus 1, that is equal to f of x y plus 1 comma y. This is given to you. So you can easily see if you have f1 plus 1, 2 plus 1. Okay, in this situation what you can say? It will be f of f1 comma 3 comma 2. Okay, so what is f1 comma 3? What that is? That is 2y. That is a 2y. That is basically 6. Okay, because this is basically y. This is y. Is this clear? So very simple point. What is f13? Because this is already given to you. Let me write here. This is already given to you that f of 1 comma y, that will be 2y. Okay, so this value is going to be 6. So finally what we got? We got f of 6 comma 2. This is what we got. Now we have to find what is f of 6 comma 2. Yes or no? Now what we have to find? We have to find what is f of 6 comma 2, right? Is this clear? So let's find out what is f of 6 comma 2. Again you can use the same. So this is x plus 1, this is y plus 1. So finally it will be same as f of x comma y, y plus 1 comma y. That will be like this. Okay. Now this is already given to you. What is given to you? This is already given to you that f of anything, f of alpha comma 1, that is alpha plus 1. Yes or no? This is already given to you that f of anything comma 1 means alpha comma 1, that is alpha plus 1. So f of This is your alpha. Let's call it alpha. Okay, so alpha comma 1, that will be finally equal to, that will be equal to alpha plus 1. Yes or no? So that will be equal to 5 2 plus 1. Is this clear? Now we have to find what is 5 2. Okay, so what will be 5 2? Let's find out. So 5 2 will be basically f of x comma y plus 1 comma y, okay, plus 1. Is this clear? So now what is this? Again, what you can do? You can consider this as alpha. This is basically your alpha. So you can see f of alpha plus f of alpha comma 1, that will be alpha plus 1. So you will get 4 2 plus 1 plus 1. Okay, and so on. Basically, you can see you are starting from 6 2. From 6 2, you are going to 5 2, then you are going to 4 2. And so on. If you continue, you will go to 3 2. Yes or no? Like this, if you continue, what will happen? So we got this f of 4 2 plus 1 plus 1. This is what we got. If you continue, what you will get? You will get f of 3 2 plus 1 plus 1 plus 1. If you continue, you will get f of 2 2 plus 1 plus 1 plus 1 plus 1. And finally, you will get f of 1 2 plus 1 plus 1 plus 1 plus 1 plus 1. And this value you already know, this is f of 1 comma y. This value will be 2 into 2, that this value will be 4. This value will be 4. So your final answer is what? So final answer is basically, that is 9. Is this clear? But let me tell you, did you use this method to solve this question? To solve this question, did you use this method? Let me know. Did you use this method to solve this question? This is actually a very slow method. Let me tell you, in the same question, if I ask you, for example, if I ask you f4 comma 4, then will you use this method? If you use this method, it will take a lot of time. Yes or no? See, the answer will be 9. But here the question is basically, what is the efficient way to solve it? Remember, the question is very simple. Anyone can solve it. But in this question, in the same question, if I ask you, for example, if I ask you what is f4 comma 4, will you use this method? If you use this method number 1, if you use, okay, like this if you do, like this if you do, remember, like this if you do, keep opening. So if you do like this, then it will take a lot of time. Okay, what will be f4 comma 4? What will be f3 comma 3? So if I ask you these questions, then it will take a lot of time. Please understand. So remember, the question is very easy. Anyone can solve this question. But here the question is, what is the efficient way to solve it? In the GATE exam, if they ask you what is f4 comma 4, and if you use this method number 1, okay, if you keep doing like this, okay, you open it, then you open it. If you do like this in the GATE exam, it will take a lot of time. So this is not an efficient way. Anyone want to suggest what is the efficient way? In this, if this same question comes in the GATE exam, and let's assume they are asking you what is f4 comma 4, then what is the most efficient way to solve it? Getting answer is not enough. Yes or no? In the GATE exam, if they ask you what is f4 comma 4, then if you are using this method, you will take maybe 5 minutes, 10 minutes. But maybe there is some other student who will take 1 minute. Okay, so remember, you can save a lot of time. You can save if you know the efficient way. So always solve the question by a efficient way. Solving question is not enough. If you are solving question in 10 minutes, I am solving question in 1 minute, then I am saving 9 minutes. And in those 9 minutes, I can solve a lot of questions. Okay, so remember, solving question is not enough. Getting answer is not enough. You should know what is the complete analysis. Also, you should know what is the efficient way, what is the most efficient way to solve the question. So please understand. Okay, is this clear? Now let's see the efficient way to solve the question. This same question we are going to solve with the efficient way. So let's see the method number 2. Okay, and that is the efficient way. Basically, look at this function. This function has 2 arguments. Yes or no? Yes or no? Look at this function. The function is given to you like this, that fx comma 1 is equal to x plus 1. f1 comma y, that is equal to 2y. Okay, so this is what the function is given to you. f x plus 1 y plus 1, that is equal to f x y plus 1 y. So this is what the function is given to you. Yes or no? Is this clear? And the question is asking what is f23. Okay, so you tell me. Here you can notice f is taking 2 arguments. So you make a table 2 by 2, basically a matrix you create. Yes or no? The best way, because here the function has two arguments, right? Yes or no? Your function has two arguments. There are two arguments in the function. So you create a xy plane, you create a table. Okay, it is very intuitive that you create a table. Just create a table. Okay, here you already know that x comma y, these are integers, these are positive integers. X comma y, what are these? Okay, what is x, what is y? These are positive integers. Positive integers. This is given in the question that they are positive integers. So because this function is taking two arguments, x comma y, two arguments you are taking. So what you can do, you can solve this question by making a table. Just make a table for this. Okay, let me make a table for this. Like this, you can create a table. Okay, xy table you can create. So let's do this. Here you can put y. So this is the column of y. Okay, this is the column of y. Yes or no? Whatever value they ask you, like this is the column of y. For example, here you have y equal to 1. Here you have y equal to 2, 3, 4, 5, 6, 7, 8, 9, and so on. Okay, here you have y equal to 1. And here you have x equal to 1, 2, 3, and so on. Okay, so very simple. Here you have x. Here you have basically x equal to 1, x equal to 2, x equal to 3, 4, 5, 6, 7, and so on. Yes or no? And so on. I hope you understood this. Okay, so very simple. So this is how you can create a table, right? Now, after creating this table, what you can do? You just observe what this function is given. See this function. Look at this. This is the actual line. Yes or no? This is the actual line. Okay, but before that, what you can do? You can fill these entries. Fx comma 1 is x plus 1. F1 comma y is 2y. So you can fill some entries. What entries you can fill? You can notice here y is equal to 1. And what is fx comma, what is this fx comma 1? What is fx comma 1? That is x plus 1. So here the entries will be like this 1 plus 1, x plus 1. That is like 2, 3, 4, 5, 6, 7, 8. These entries you can put here. Similarly, what is f1 comma y? Similarly, what is f1 comma y? That is equal to 2y. Okay, so you can see that is equal to 2y. So here when x is 1, then the answer will be 2y. So that will be like 4, 6, 8, 10, 12, 17, 16, 18, and so on. Right? Agree with me? Okay, so and so on. Like this you can do. Okay, so these entries are very easy to fill. So you can fill these entries. So you can see this entry was 2, 3, 4, 5, 6, 7, 8. And these entries are basically 4, 6, 8, 10, 12, 14, 16, 18. Okay, so like this you can fill the entries. Now what? Now you understand what this means. What this means. The question is saying that fx plus 1, y plus 1, that is equal to f of fx comma y plus 1 comma y. Okay, now you understand this. For example, if you know what is this value, please understand. Okay, this is your table. In this table, let's assume if you want this value, see, you want x plus 1, y plus 1. So if this is your fxy, yes or no? This is your fxy. So this will be your fx plus 1, y plus 1. Agree with me? This will be your fx plus 1, y plus 1. Correct? Okay, so this entry is basically, this is what you want to find out. Fx plus 1, y plus 1. This is what you want to find out. You want to find out this entry. Is this clear? You want to find out this entry. So if you want to find out this entry, then what that will be? Please understand, this is what you want to find out. Okay, let's call it this entry. This is what you want to find out. Now tell me, if you want to find out this entry, then what you will do? To find out this entry, what you will do? Very simple. You will find this entry. And where is this entry? Tell me. Okay, here, where is this entry? Please notice. If you find this entry, to find this entry, this is what you want to find out. This is what you to find out. Okay, if you want to find out this entry, first you have to find this entry, fxy plus 1. Where is this entry? This entry is just above. Yes or no? This entry is here. This is your, look at this entry. This entry is your fxy plus 1. Okay, so this entry is your fxy plus 1. Now let's assume that this entry is alpha. Let's call this entry alpha. Now finally what you need to find out? You need to find out f alpha comma y. Yes or no? What you need to find out? You need to find out f alpha comma y. Okay, now you have to find out f alpha comma y, and this is the row of y, and this is the row of y plus column of y plus 1. Yes or no? This is the column of y plus 1. This is the column of y. This is the column of y. This is the column of y plus 1. This is the row of x. This is the row of x plus 1. What you need to find out? You need to find out now f alpha comma y. Okay, yes or no? Now you need to find out. Basically, now your task is what is f alpha comma y. In which column you will get it? In which column you will get it? F alpha comma y. You will get it in this column. So in this column you go where you have x equal to alpha. Yes or no? You go where you have x equal to alpha. Here you have x equal to alpha. And finally this entry, let's call it b, let's call it maybe anything. For example, let's call it z. This will be your answer. This z will be your answer. Okay, I hope you understood this. Please tell me, did you understand? Let me again just tell you quickly. If you want to find out, let's assume this is the entry you want to find out. If you want to find out this entry, then remember what you need to do. First you find out this entry. Okay, first you find out this entry. Okay, let's call this entry alpha. Let's call this entry alpha. Then what you do, just in the previous column, in this previous column you go where you have x equal to alpha. Okay, where you have x equal to alpha. So in the previous column you go where you have x equal to alpha. This entry, if this is z, then this will be z. Okay, I hope you understood this. Please tell me, is this clear? Very simple. If you want to find this entry, then very simple. First you find this above. Okay, means one above. So this entry you find, and once you find this entry, go in the previous column. Go in the previous column where x is alpha, and this value you find, this value will be your answer. Okay, this is the analysis of this given function. Please tell me, did you understand? Let me know. Did you understand the analysis of this given function? Please tell me. Anyone has any doubt in this? See, I am telling you how to analyze the given function. In the GATE exam, if there is a 2-mark question, okay, 2-mark question, and if they ask you what is f4, 4, maybe f5, 5, okay, if they ask you some big value, then how you can solve it efficiently. And remember, very simple analysis, because your function has 2 arguments. So because your function has 2 arguments, you can create a table. You can create a xy plane, you can create. Yes or no? You can put x on the row and you can put y on the column. Now I am just telling you how to find each entry. Please tell me, did you understand this analysis? Let me know. You can take your copy pen. If you want to understand, I can say more clearly. If you are having some confusion, then take a copy pen. Don't watch like a movie. This is a lecture. Okay, this is a study lecture. So don't watch it like a movie. Take your copy pen. You will understand in a better way. Always take your copy pen. If you want to understand in the best way possible, for your benefit, take a copy pen and do it. Okay, very simple. So this is the analysis of the given function. Now let's find out. Now let's fill the entries. Okay, now you are ready to fill the entries. So let's see how to fill the entries. So let's see how to fill the entry. This entry. Just quickly tell me. Let's fill all these entries. You tell me how to fill this. Now you are expert. How to fill this? Please tell me. I want to fill this entry. So how to do that? Very simple. First you find out this. Let's call it alpha. Okay, let's call it alpha. Then what you do? In the previous column, you go where you have x equal to alpha. In the previous column, you go where you have x equal to alpha. And this value will be your answer. This value you can put here. So this entry will be 5. Is this clear? This entry will be 5. I hope you understood. So remember, this entry is going to be 5. Very simple. This entry will be 5. I hope you understood. Yes or no? Is this clear? So very simple. This entry has become 5. Did you understand this? Please tell me. Okay, tell me the next entry. I am asking the next entry. You tell me what that next entry will be. Quickly tell me what will be this entry. Let me know. Quickly tell me what will be this entry. I am asking what is this entry. What is this entry? Very simple. If you want to find this entry, first you find this entry. This is alpha. Now in the previous column, you go where x is 5. In the previous column, you go where x is 5. This value you can put. this value you can put here. So remember, this entry will be what? This entry will be 6. Is this clear? This entry is going to be 6. Okay, very simple, right? So finally you got this entry also. Now you can see 4, 5, 6 and so on. This will be 7, this will be 8, this will be 9, this will be 10. You can see the pattern. Okay, so these entries are gone. The question was asking F2, 3. The question was asking this entry. Now you tell me what will be this entry. The question was asking what will be this entry. So tell me what this entry will be. Let me know. What will be F2, 3? Just find out what that will be. Let me know. Please tell me. So what this entry will be? Again, very simple. If you want to find this entry, then what you need to do? Just take this entry. This is your alpha. This is your alpha. In the previous column, go where you have x equal to alpha. Okay. So go where you have x equal to alpha. Means in the previous column, you go where you have x equal to alpha. So this 9 will be your answer. Yes or no? This 9 will be your answer. Is this clear? This 9 is going to be your answer. So remember, this entry is going to be 9. This entry is going to be 9. Okay, I hope you understood. So the question was asking what this entry. So you can see F2, 3, that is 9. Is this clear? F2, 3, that is 9. What about the remaining? What is F33? Tell me, what is F33? Now what that will be? What will be this entry? Let me know. What is going to be this entry? For example, if I ask you what is this entry, very simple, very simple. First you find this entry. Let's call it alpha. Okay, let's call it alpha. Now, in the previous column, you see where x is 9. In the previous column, you just see where x is 9. In the previous column, when x will be 9, then what value you will get? When x will be 9, in the previous column, you find where x is 9. Where x is 9. In the previous column, you find where x is 9. So when x is 9, then that value is basically 12. This value will be your answer. Okay, this 12, this will be your answer. So you can put this will be 12. Okay, is this clear? So now this question is very easy, right? Now this value will be 12. Now you can fill all these entries 6, 9, 12. So this will be 15, 18, 21, 24 and so on. I hope you understood. Okay. I hope you clearly understood. Now just tell me this last answer. Tell me what is this value. Just tell me this value, that's it. You tell me this value. So what this value will be? So if you want to find this value, then first you find this is your alpha. In the previous column, you find where x is 8. In the previous column, you find where x is 8 in the previous column. So that will be 27. This 27 will be your answer. Okay, in the previous column, you find where x is 8. Okay, so this 27 will be your answer. So here you can put 27. Okay, remember, here you can put 27. So that's it. I hope you understood. So this is the complete analysis of this question. Please tell me, did you love this question? Let me know. Did you learn something new in this question? This method did you learn? See, in the GATE exam, they can ask you this type of question. They can ask you where the function has two arguments, fx, y. This type of question they can ask you. They can ask you what are the value of f33, f44, f55, yes or no, f5, 4. So they can give you this type of function they can give you. Now, can you analyze this type of function very efficiently? Let me know. Now, whatever I ask you, you can easily solve it. Yes or no? This is the complete analysis of this function. What this function is doing. What the behavior of this function I told you. Okay, let me know. Did you understand? Please tell me. So this is how you can calculate. Okay, so this was the complete analysis of this question. So this was an efficient way. I hope you loved this question. Through this question, because of this question, did you learn something new? A new approach to solve a whole variety of functions. A whole variety of new questions you can solve using this method, using this approach. This is an efficient approach. Okay, let's move on to the next question. Let's solve this question. from theory of computation? Some grammars are given to you and the question is asking which of these grammars is unambiguous. Which of the following context free grammar is unambiguous? Okay, so these grammars are given to you. Now let's see which of them is unambiguous. See, a context free grammar is ambiguous. When it will be ambiguous? When can I say a context free grammar? If you have a context free grammar G, that is ambiguous. When that will be ambiguous? That is ambiguous if and only if there exists some string. Okay, there exists some string belonging to the language. There exists some string belonging to the language which has more than one parse tree. Yes or no? Which has more than one parse trees. So very simple point. If you have a context free grammar G, when can you say that is ambiguous? A context free grammar is ambiguous if and only if there exists a string in the language of this grammar which has more than one parse tree, which you can derive using more than one parse tree. So in this question, actually all the grammars are ambiguous. Okay, every grammar is ambiguous. The question is asking which grammar is unambiguous. So actually all of them are ambiguous. Actually all are ambiguous. All these grammars are actually ambiguous. Okay, so because all are ambiguous, so here for this question we have given marks to all. Okay, this question, I can say this question has become marks to all. This will be marks to all because every grammar is actually ambiguous. So we have given marks to all for this question. Okay, now let's see how they are ambiguous. For example, look at the grammar number 1. Why this is ambiguous? The grammar number in option A, what is that? That is S deriving. You can replace S with AX or YC. And X you can replace with BC. And Y you can replace with AB. Okay, so this is the grammar that is given to you. Now in this grammar you can easily see, look at this string W equal to ABC. For this string there are two parse trees. For this string you can create total two parse trees you can create. Okay, one parse tree you can create like this. See what you can do. From S you can go to AX and from X you can go to BC. So this is one parse tree that you can create. The another parse tree that you can create, that will be like this. S you can replace with YC and this Y you can replace with AB. So you can easily see that here you have ABC and here also you have ABC. Okay, so very simple. For this ABC, for this string you have two parse tree. So this is definitely ambiguous. Option A, that is ambiguous. This grammar is ambiguous. What about option B? Option B is saying S deriving empty string this or this. Okay, this is your option B. Now in this you can easily see this string. Look at this string W equal to, look at this string. This string you can derive in two ways. Okay, this string you can derive in two ways. What you can do? One parse tree will be, you can just directly derive. Yes or no? You can directly derive. This will be one parse tree. Another parse tree will be, you can derive this S you can replace with this one, and then finally this S you can replace with empty string. So you can see for this string there are more than one parse tree. For this string I can say there are two parse trees. You have total two parse trees. Is this clear? So I hope you understood this. Actually in this grammar, let me tell you, look at this option B. Again let's look at this option B. Option B is saying empty string, then you have this and then you have this one, right? Okay, first of all, what is the language here? What will be the language of this grammar? What is going to be the language of this grammar? That will be basically, okay, open parenthesis power n, close parenthesis power n. Okay, so n is greater than equal to 0. Okay, this will be your language actually. Okay, this is going to be the language. The language is something like a power n, b power n, where n is greater than equal to 0. Okay, where a is basically open parenthesis and b is basically close parenthesis. This is the language. And here, other than empty string, every string is ambiguously derived. Okay, in this grammar actually, you can see other than empty string, every other string is ambiguously derived. Every other string has two parse tree. Every other string has two parse tree. Has two parse trees. Okay, every string will have two parse tree. Basically, Every string is ambiguously derived. Every other string is basically ambiguously derived. I can say every other string ambiguously derived. Okay, so I can say that except empty string, every other string ambiguously derived. Ambiguously derived. Okay, ambiguously derived. So I can say like this. Okay. Now let's see what about the option C. Option C, that is also ambiguous grammar, because which string will have more than one pass tree? Can you give me at least one string which will have more than one pass tree? So let's look at option C. What option C is saying? Option C is saying that S you can replace with empty string, you can replace with this one, and you can replace with this one. Here also you can easily see some string. Can you give me some string which you can ambiguously derive? Yes, very easily. For example, consider this string W equal to this string. Now you can see either you can derive this string like this. Okay, this is one pass tree for this string. The another pass tree for this string will be, you can replace S with SS. Now this S you can replace with open parenthesis, S close parenthesis. Now what you can do, you can send this to epsilon, you can send this to epsilon. Okay, so like this. So this is also, this string has more than one pass tree, so this is also ambiguous. What about option D? What about option D? Look at option D. Let's look at option D. Option D is saying that you can replace this with S or open parenthesis. Okay, now here also you can see this empty string. Look at this empty string. This you can ambiguously derive. Either you can do like this. This is one pass tree. Another pass tree will be S you can replace with S, and then S you can replace with empty string. Okay, so there are two pass tree for this empty string. Is this clear? So very simple. Every grammar is basically ambiguous. So that is the reason for this question, marks to all. Okay, let's move on now. Now let's solve this question. Group theory question, discrete mathematics. So let's solve it. What this question is saying, that a group is given to you. There is a group G. In this group G, B, C are the elements. Okay, B, C, these are the elements. And the question is saying, if B power 5 equal to C power 3 equal to identity element, E is the identity element. Okay, then the inverse of this element, B square, C, B power 4, C power 2. Okay, what will be the inverse of this element? See, there is a property, very simple property in the group. In any group, what will happen? In any group, okay, whatever group you take, in any group, you can see that if you have AB equal to E, if you have AB equal to E, then it simply means that B will be inverse of A. Okay, see, this will happen if and only if, this is if and only if, this is if and only if, this will happen if and only if A is B inverse, or I can say B is A inverse. Okay, you can say A is B inverse, or you can say B is A inverse. Okay, so remember, this is if and only if. Means in any group, if this happens, that AB equal to E, if this happens, then remember, very simple point, this will happen if and only if A equal to B inverse, or I can say B equal to A inverse. So this is the point. So remember, in this question, you can see B power 5 is given to you, that like C power 3 is given to you E. See, in the question, they are saying C power 3 is E. Now you can notice one thing. Here you can find the C inverse. From here, what will be the C inverse? Tell me. You can easily find the C inverse. What that will be? See, remember, C power 3. What you can do? You can write it C power 1, C power 2, that is equal to E. Now you can use this property. You can use this property. If AB equal to E, then A will be B inverse, B will be A inverse. Okay, yes or no? So you can see C square is equal to E. So from here, this will happen if and only if C equal to C square inverse, or I can say C square is equal to C inverse. Okay, is this clear? C square is equal to C inverse. I hope you understood. So very simple point, C square is equal to C inverse, or I can say C inverse is equal to C square. C inverse is equal to C square, or I can say C square is equal to C inverse. So like this you can easily find. Is this clear? Or I can say that what will be C power minus 2? That is basically C square inverse, and C square inverse is C. Okay, C square inverse, that is C. Or you can say like this, that C power minus 2, that will be C inverse power 2. C inverse power 2. And C inverse is a C square. Okay, C inverse, that is C square. So here you can get C power 4 also you can get. Okay, you can get C power 4 also. So anyway, basically this is how you can find out. I hope you understood. So remember, just use this property. See, this is an important property. In every group this will happen. In any group, whatever group you take, this property is there, that this x y equal to e, identity element, this must be identity element. This must be identity element. So xy will be equal to e. This will happen if and only if, this is a two-way. This will happen if and only if x is equal to y inverse, okay, and y is equal to x inverse, right? Yes or no? X is equal to y inverse, y is equal to x inverse. So very simple point. So this is the idea. Now let's solve this question. The question is asking what the inverse of b square c b power 4 c square. The question, what the question is asking? Inverse of b square c b power 4 c square. What will be the inverse of this? This is what the question is asking, right? Yes or no? So let's find out. First of all, you already know this property, this another property in a group. Let's see another property of a group. Note, in any group, whatever group you take, okay, whatever, in any group, whatever group you take, if you do xy whole inverse, xy whole inverse, that will be basically y inverse x inverse, right? Similarly, for example, if you do abcd whole inverse, that will be basically d inverse c inverse b inverse a inverse. Okay, so this is a basic property of any group, whatever group you take, this is the basic property. So you can see, if you want to find the inverse of this, then that will be basically c power minus 2 b power minus 4 c inverse and b power minus 2. Yes or no? Is this clear? Because if you have abcd inverse, that will be d inverse c inverse b inverse a inverse. If you have xy whole inverse, that will be y inverse x inverse. So you can see this is what you will get. Now this is already given to you, that b power 5 is equal to e. From here you can easily find what is b power minus 4. See, this is given to you. What this means? This means b power 4 is equal to e. Yes or no? b power 4, that is equal to e. Now from here, what you can say? You can easily find what will be b power 4 inverse. What will be the inverse of b power 4? That will be b. That will be b. Yes or no? Is this clear? The inverse of this will be b. The inverse of b will be b power 4. From here, if I ask you what is b inverse, that will be b power 4. Okay, so you can see b power 4 inverse will be b. So this value, that will be b. Very simple. This value is going to be b. Similarly, c inverse, that will be c power 2. We have already seen. C power 2 inverse, that will be c. We have already seen. And b power minus 2, that will be b power 3. Why? What is the reason? See, the reason is very simple. B power 5 is given to you, that is e. Okay, you can write this b power 2, b power 3. Now you can easily see what will be b power 2 inverse. The inverse of this will be b power 3. Okay, if you want to find the inverse of this, which means b power minus 2, that will be b power 3. Okay, or similarly, from here, if you want to find what is b power 3 inverse, that means b power minus 3, that will be basically b square. Okay, so you can see this will be b cube. So your answer will be cb c square b cube. This is going to be your answer. cb c square b cube. cb c square b cube. So you can see the answer will be option D. Okay, this is the answer for this question. Is this clear? Please tell me. So this is a very simple question from group theory. Okay. Anyone has any doubt in this question? Let me know. Please tell me. Do you have any doubt in this question? Let me know. So very simple question from group theory. Now let's move on. Now let's solve this question. This is another beautiful question in this test. So you can see a binary relation over set A is called Go relation if for all x, y, z in A, for all elements in A, if x related to y and x related to z, if x related to y and x related to z, then y related to z. This is the new relation that is given to you. A new relation has been defined. We are calling it Go relation. This is a new relation that has been defined. Now the question is asking which of the following are true for this Go relation. Some options are given to you. If R is reflexive and Go relation, then R is symmetric. If R is reflexive and Go relation, then R is transitive. If R is Go relation, then R is reflexive. If R is equivalence relation, then R is Go relation. Some options are given to you. Now let's check it out. Before we solve this question, let me tell you, this is a standard question from Stanford University. This question is taken from Stanford University. You can notice the same question as it is, we have taken from Stanford University. So this is a standard question. Okay. In this Stanford University, they are calling it Euclidean function relation. Okay. They are giving this name. So you can see a new definition they are giving. Look at this. Okay. A new definition is given. A new relation is defined. That is Euclidean. You can see Euclidean relation. This is the only difference. We are calling it Go relation. Okay, this is the only difference. You can see a new relation has been defined and the same question is here. Okay, now let's solve this. So this is a Stanford question. Now let's solve it. So what the definition of this Go relation? Please understand this. This is a relation on set A. So this is a relation. You have a relation R on set A. Okay, on set A. And we are saying that R is Go relation. When can I say R is a Go relation? When can I say that R is Go relation? R is Go relation if and only if what should happen? See, this would happen that for all x, y, z, they can be same or different. Please understand. For all x, y, z, they can be same or different. When I say x, y, z belonging to A, x, y, z, they are belonging to A. So they can be same or different. X, y, they can be same, they can be different. X, z, they can be same, they can be different. Y, z, they can be same, they can be different. Please understand, when we say for all x, y, z belonging to A, so x is also belonging to A, y is also belonging to A, z is also belonging to A. So they can be same or different. X, y, z, they can be same or different. Okay, so you can see R is Go relation if and only if for all elements in A, whatever elements you take. This question is saying that if x is related to y and x is related to z, then y will be related to z. This is what the question is saying. Notice, let's create the diagram. The diagram is like this. If x is related to y and if x is related to z. Okay, if this happens, please notice. If this happens, then y will be related to z. Okay, of course, z also will be related to y. Yes or no? Yes or no? Because for all x, y, z, this will happen. Okay, so this is the diagram. Please understand, this is the Go relation feature. This is the Go relation. Go relation says that if this happens, if this element is related to this element also, and x is related to y also, if this happens, then y will be related to z, z will be related to y. Yes or no? Then I can say z will be related to y. I can also say y will be related to z. Is this clear? Please tell me. Did you understand? Please tell me. See, here this is given to you. Look at this. This is given to you that if x is related to y, if this happens, if x is related to y and x is related to z, if these two things happen, then I can say y will be related to z. But you can see that this same statement I can also write. That if x is related to z and x is related to y then what will happen? Then z will be related to y. Yes or no? So then z also will be related to y. Is this clear? So you can see, then y will be related to z, then z will be related to y. I hope you understood this. Okay, so this is the given relation. Did you understand? Please tell me. Very simple point. Remember, again I am telling you, if this element A or maybe this element alpha, let's call it alpha, if this alpha is related to beta and this alpha is related to gamma, then remember, beta should be related to gamma and gamma should be related to beta. Okay, because this definition is given to you for all x, y, z. You can take any x, y, z. X, y, z, they can be any elements from the set A. So did you understand the definition? Now once you understood the definition, now let's see each option one by one. Let's see the first option. if R is reflexive and go relation, then what you can say? What you can say about symmetricity? Okay, let's look at option A. Option A is saying that if R that is reflexive and go relation, then what you can say about symmetric? Then can you guarantee R will be symmetric? Then can you guarantee R will be symmetric? Let's check. Can you guarantee R will be symmetric? See, for symmetricity, if you want to check symmetricity, what should happen? Assume X is related to Y. Okay, assume X is related to Y. Then if what we have to prove, please tell me. For symmetricity, what we have to prove? Assume X is related to Y. Now let's check. Can you guarantee that Y will be related to X? Yes or no? Can you guarantee? Can we guarantee? Can we guarantee? Can we guarantee that? Can we guarantee that Y will be related to X? Yes or no? Is this clear? So just assume that X is related to Y. Now can you guarantee that Y will be related to X? So very simple. Now assume X is related to Y. What it means? It means X is related to Y. And because it is reflexive, okay, it is given that R is go relation and reflexive. So because it is reflexive, so X is related to X also. Yes or no? Is this clear? Because it is reflexive, so X is related to X. And because it is go relation, now what will happen? Because of go relation, what will happen? Because of go relation, it is given that R is go relation. Now because of go relation, what will happen? Y will be related to X. Y will be, because of go relation, what will happen? Y will be related to X. That's it. Okay, so symmetricity is guaranteed. Yes or no? Yes or no? So symmetricity is guaranteed. Is this clear? Please tell me. See, the question is very simple. You are checking for symmetricity. Let's look at option A. In the option A, notice one thing, that relation R is given to you that it is reflexive also and it is go relation also. Two things are given to you. Okay. Now the question is asking, can you say it will be symmetric? R is reflexive also, go also. Now just assume that X is related to Y. Just assume X is related to Y. Now we can prove that Y will be related to X. Okay, because you are assuming X is related to Y. Because of reflexive, X will be related to X because of reflexive. Because of reflexive. Now because of go relation, what will happen? Because of go relation, what will happen? This Y will be related to X. Yes or no? Because of go relation, this Y will be related to X. So this is a very simple point. I hope you understood this. Okay, so you can see this is happening because of reflexive, and because of go relation, this Y will be related to X. Okay, I hope you understood this. Please tell me, did you understand? So option A, that is true. Okay, the question is asking which option is true. So option A is definitely true. Okay, what about the option B? What you can say about transitive? Can I say R is transitive? Let's look at option B. What option B is saying? Option B is saying that R is reflexive and go relation. Okay, R is reflexive and go relation. Now, can you say R will be transitive? What you can say about R is transitive? The question is asking, can I say R will be transitive? You have to check transitive or not. Okay, let's check it. See, for transitivity, if you want to check for transitivity, what you will do? You will assume that X related to Y, Y related to Z. Okay, yes or no? This is what you are going to assume. You are going to assume that X is related to Y and Y is related to Z. Right? Yes or no? Now, can you prove that X will be related to Z? This is the question. Assume X is related to Y, Y related to Z. Now, can we prove that X will be related to Z? This is what we need to do, transitivity. Okay, so can we prove that X will be related to Z? Okay, so let's check it. So you assume X is related to Y, Y is related to Z. So X is related to Y, Y is related to Z. Yes or no? We have already seen this will be symmetric. Do you agree? We have already seen in the option A, we have already seen this will be symmetric. This implies symmetric, we have already seen. Okay, this implies symmetric, we have already seen, right? So, if you assume that X is related to Y, Y is related to Z, if you assume this, then because of symmetry, what will happen? Then because of symmetry, because we know it will be symmetric, we have already seen that it will be symmetric in the option A. We have already seen if a relation is reflexive and go relation, then it will be symmetric. We have already seen. So because of symmetric, what will happen? It will happen that x will be related to y and z will be related to y. Yes or no? Yes or no? So I can say x will be related to y, z will be related to y, or I can say y will be related to x. Okay. So you can see basically because of symmetry, let me tell you, because of symmetry, this will happen. See, this is what you are assuming. Okay, this is what you are assuming. This we have assumed. This we have assumed, and because of symmetry, x will be related to y. Sorry, y will be related to x. Is this clear? Please tell me. Because of symmetry. Okay, this is what I am telling you, that because of symmetry, this will happen. Is this clear? And this is what we have assumed. This is what we have assumed. So finally, now you tell me. Okay, so you tell me now, what will happen now? Now what will happen? So you can see what I'm saying. First you assume, you are checking for transitivity. So first you assume x is related to y. You assume y is related to z. This is what you assume first. Now because of symmetry, what will happen? Okay, so I can say because of symmetry, there is a symmetry here, because you know that reflexive and go relation, that implies symmetric. We have already checked. Okay, so because of symmetric, y will be related to x. This is already given. Now because of these two things, what I can say, y is related to, okay, y, this will be y. So you can see y is related to x, y is related to z, and because of go relation, what will happen? Please tell me, because of go relation, what will happen? X will be related to z or not? Yes or no? Because of go relation, x will be related to z. Okay, x will be related to z. Because of go relation, x will be related to z. So this is your transitive. We have proved that this will be transitive. So this is also correct. R will be transitive. What about the next? If R is go relation, then can I say it will be reflexive? If R is go relation, can I say it will be reflexive? No, this is not correct. Option C is not correct. See, option C is not correct. What this option C is saying, that if R is go relation, okay, if R is go relation, then can I say R will be reflexive? The answer is no. Okay, can you give a counter example? Can you give me a counter example? Yes, you can give a counter example. For example, consider this relation. Okay, consider first of all this set. I am giving you a set, like consider this set A, B, C. On this set, you consider this relation which is A. Okay, just consider this relation. Now you can notice this is go relation. This is a go relation. Yes or no? Every condition is satisfied. This is a go relation, but this is not reflexive. This is a go relation. This is a go relation, but this is not reflexive. So you can easily see this option 3, that is a false. Okay, what about this one? If R is equivalence relation, then it is go relation. Can you prove R is equivalence relation, then it is go relation? Let's look at option D. Option D is saying if R is equivalence relation, it is already given to you that R is equivalence relation. Then can you prove, then can you guarantee that R will be go relation? Can you guarantee or not? This is what we need to check. Then can I say R will be go relation or not? So this is very simple. Let's check it will be go relation or not. So to check go relation, what you will do? If you want to check go relation, what you will do? You will assume that x is related to y and x is related to z. Yes or no? This is what you are going to assume, that x is related to y, x is related to z. Now, if you want to check for go relation, then basically, can you guarantee that y will be related to z? Yes or no? Basically, can we prove that y will be related to z? Yes or no? This is what we need to check. Agree with me? Because we need to check for go relation. Okay, so remember, just assume that x is related to y, x is related to z. Assume this. Now, to check for go property, if you want to check for go property, then can you prove that y will be related to z? Can you prove that? Okay, let's check. This is given that it is a equivalence relation. Because it is equivalence relation, so it is reflexive, symmetric, transitive. Yes or no? And basically, we just need to check, can I say y will be related to z? This is what we need. Yes or no? So you can see, because R is reflexive, transitive, symmetric, So because of symmetric, what will happen? Because of symmetric, what will happen? Can I say because of symmetric? I can say because of symmetric. Because of symmetric, I can say z is related to x. Yes or no? Because of symmetric, z is related to x. Now, now you can see because of symmetric, y is related to x. Okay, finally, what we need? We need y related to z. Can I say y will be related to z? Notice one thing. So y is related to x and x is related to z. Okay, you don't need this. Okay, you don't need this. You can see because y is related to x and x is related to z, then because of transitive property, equivalence relation is transitive. Equivalence relation is transitive, right? Yes or no? Equivalence relation is transitive. So because of transitive property, y will be related to z. And this is what we wanted to prove. This is what we wanted to prove. Yes or no? Okay, so I can say, yes, it will be a go relation. Yes, it will be a go relation. Did you understand? See, very simple point. Assume that R is equivalence relation, because option D is saying if R is equivalence relation, can you prove that R will be go relation? Okay. So if you want to check for go relation, just assume that X is related to Y, X is related to Z. And finally, we have to prove that Y is related to Z. This is what we have to prove. So what you can do, very simple. It is already given that R is equivalence relation. So you can use the symmetric property. So Y will be related to X. Now Y will be related to X, X is related to Z. You can use the transitive property. Because it is given that R is equivalence relation, so you can use transitive property and you can see Y will be related to Z. So very simple. So option D, what I can say about option D, that also will be true. Yes or no? Answer will be ABD. For this question, the answer is ABD. So final answer, let me tell you, the final answer is ABD. Okay, this is a very beautiful question and this is very similar to GATE 2021 question. In GATE 2021, there was a question on circular relation. Yes or no? Anyone remember this? In the GATE 2021, there was a question, circular relation. So this is a very similar question to that. Okay, so remember, this is a very beautiful question. I hope you understood the analysis. So tell me, are you confident in the GATE exam? See, in the GATE 2021, they have defined circular relation. If you remember, you can check the GATE 2021 question. In the GATE 2021 question, they have defined a new word. A new word they have defined, that is circular relation. This new word they have defined, a circular relation. This is what I am saying, that basically, similarly, like this question, we have done the analysis. For this question, we have done the complete analysis. Similarly, you can do the complete analysis of this question. Then you will feel confident. Whatever question comes in the GATE exam, you can handle it. In the GATE exam, they can define some new relation. Okay, yes or no? They can define something new, they can define. You can analyze and you can solve the question. Is this clear? Please tell me. So this question, is this clear to everyone? So this was a beautiful question. Okay, let's move on. Now let's solve this question. This is another good question in this digital logic, in this All India mock test 2. So this question I have already provided you the video solution. Okay. So I have already provided you a video solution for this, so you can check it out. So just go to this question. Okay. Under this question, I have already provided you video solution, so you can check it out. Okay. You can check these. Is this clear? So the video solution is already provided for this question. So you can just check it out. This is a beautiful question, let me tell you. And this question will clear many misconceptions. Okay, if you have some misconception, then those misconceptions will be clear in this question. So I tell you, I can say, I request you to watch the video solution. Okay, for your benefit. So these two video solutions you should watch. This video, also this video. These two videos you must watch. So go to this question. Under this question, I have already provided the detailed video solution. You can see is already provided. Okay, let's move on. Now let's solve this question from the discrete mathematics. This is another beautiful question. Let's solve it. What this question is saying: acceptable input for a certain pocket calculator is a finite sequence of characters each of which is either a digit or a sign. Okay, so you have a pocket calculator, and for this pocket calculator, acceptable input is basically a finite sequence of characters. Every character is either a digit or it is a sign. Okay, the first character must be a digit, the last character must be a digit. Any character that is a sign must be followed by a digit. Means if you have a sign, then it must be followed by a digit. Okay, there are 10 possible digits and there are 4 possible signs. This is already given to you. The question is saying, if nk denotes the number of such acceptable sequences having length k, then nk is given recursively by this formula. Okay, you can find this nk recursively by this formula. The question is asking what is the value of a plus b. So this is another beautiful question. Let me tell you, you can solve this question by 2 methods. Let me tell you both the methods. Let me tell you. See, let me tell you the method number 1. Let me tell you method number 1. That is a direct method. Basically, look at this question. Acceptable input. What is acceptable input? What is a acceptable input? Acceptable input is basically a finite sequence of characters. Some conditions are given to you. A finite sequence of characters. Okay, a finite sequence of characters where the first character must be a digit, the last character must be a digit, and the question is saying if there is some sign. Okay, if there is some sign, any sign character, yes, if there is a sign character, then it must be followed by digit. Okay, this you cannot put sign here, it must be followed by a digit. Is this clear? So every sign must be followed by a digit. So this is what the question is saying. I hope you understood. Okay, so very simple point, that this is the input. Okay, now let's solve this question. The question is saying that already this equation is given to you. Nk is equal to a nk minus 1 plus b nk minus 2 for k greater than equal to 3. And what is nk? Nk is number of such acceptable inputs, number of such sequences having length k. Yes or no? This is the number of sequences. This is the number of valid sequences, acceptable sequences of length k. Of length k. So you tell me how many valid sequences of length 1? Can you tell me? Can you tell me? See, what is nk? Nk is basically the number. This is the number of valid sequences. This is the number of valid sequences, okay, of length k. Of length k. Yes or no? So you tell me what is n1? N1, what that will be? N1, what that will be? N1 means only one character. You already it is given that first and last character must be digit. This is already given to you. First character must be digit, last character must be digit. Yes or no? So first and last character must be digit. So this must be a digit. This must be a digit. How many digits are there? Total 10 digits are there. Yes or no? Total 10 digits we have. The question is already saying there are total 10 digits. Look at this. There are 10 possible digits. So you can see n1 will be what? That will be 10. Yes or no? So you can see n1, that will be 10. What will be n2? Please tell me what will be n2. N2 means 2 characters. The question is saying the first character must be a digit. Okay, and the second character must be a digit. Both must be a digit. So you can see digit. So there are 10 ways here. You can put any digit. Here also there are 10 ways. You can put any digit. So n2 will be what? That will be 10 into 10. That will be 100. Yes or no? n2 will be 100. Now what will be n3? What will be n4? You just tell me what will be n3, n4. See, this equation is given to you. Nk equal to a nk minus 1 plus b nk minus 2. And this equation is true when k is greater than equal to 3. The question is saying k is greater than equal to 3. Then this equation is satisfied. You tell me. These are the two variables. We have to find a comma b. Yes or no? We have to find a comma b. If you want to find two variables, then how many equations you need to create? If you need two variables you want to find, a comma b, you want to find a comma b, then how many variables you need, how many equations you need to create? If you want to find two variables, there are two variables here, a comma b, then how many equations you need to create to find two variables? Very simple, two equations you need. Yes or no? So very simple, you create an equation for n3, you create an equation for n4, And from these equations you can easily find two variables. These two variables you can easily find, yes or no? Because you have two variables. If you want to calculate two variables, then two equations are needed. You need total two equations, yes or no? So very simple, you just create two equations. Okay, these two equations n3 n4, these equations you can create, you create, and then you can find a comma b. So what will be n3? Let's check it out. What will be n3? See, n3 means, first you calculate what is n3. N3 is like this. There are three characters. Already it is given that first character must be a digit and the last character must be a digit, yes or no? So there are 10 ways for the first character and there are 10 ways for the last character. Now here you can either put a digit or you can put a sign, yes or no? Here I can either put a digit or I can put a sign, agree with me? So very simple, here either I can put a digit or I can put a sign, either sign or digit. So basically here how many choices I have? Here I can put a sign or I can put a digit. So how many choices I have? There are total 14 choices because 4 signs and 10 digits. You can see 10 possible digits for 4 possible signs. Okay, so you can see very simple that here you have 14. So this is what I'm saying, that you have 14 choices. So n3 will be what? N3 will be 14 into 10 into 10. So that will be 1400. This will be n3. And what will be n4? You tell me n4 also. What will be n4? You calculate n4 also. So n4 means 4 characters. Here you can put any digit, right? Here you can put any digit. Here you can put any digit. So there are 10 ways here. There are 10 ways here. The first and last character must be a digit. Okay. Now what you can do? See, these two cannot be sign. Yes or no? These two, they cannot be sign. Let me call it position. See, let me call it x, let me call it y. Now what this x comma y can be? X comma y, they cannot be sign. Yes or no? You cannot keep them sign because every sign must be followed by a digit. Yes or no? So you cannot put sign here. You can put digit. You can put digit, or you can put sign digit, or you can put digit sign. Yes or no? These things you can do. These three things you can do. Okay. So you tell me, if you do this, then digit. So that will be what? How many xy? Or I can say, just calculate n3. N4. N4 will be, here basically it will be 10 power 4. Okay. Here basically it will be what? Tell me. It will be 4 into 10 power 3. And here it will be 4 into 10 power 3. Yes or no? So you can add all of them. That will be your n4. So what will be n4? That is, just calculate what is n4, n3. So let me tell you. Already we have found that n1 is 10. N2, what was n2? That was 100. N3, that was 1400. N4, that is what? That is 10,000. Okay, this is 10,000. This is 4,000. And so this is 8,000, right? So I think this is 18,000. Okay, so this is your, these values you have. Now two equations you can create. What you can do? You can create two equations. So one equation you can create is, you can see n3 will be a n2 plus b n1. Okay, so what is this equation? N2 is already 100. So this will be 100a plus n1. See, n2 is already 100. That you already know. N1 is already 10. So that will be 10b. N2 is already 100. So one equation you got. This is the first equation. What is the second equation? The second equation is a n3 plus b n2. So what that will be? That will be a n3. Okay, a n3 is what? N3 we have already found, that is 1400. So it will be 1400a. It will be 1400a plus n2, that is 100. So 100b. Now two equations you have. You can easily solve these two equations. So let me quickly solve them. So you can easily see that there are total two equations. One equation is 100a plus 10b is equal to n3, and the n3 is already 1400. Also the another equation is 14,000a plus 100b is equal to n4. N4 is already 18,000. Okay, so you can just cancel some values. Like here you can cancel. Okay, what you can do basically, here you can cancel this you can do, and here also you can basically cancel these. Okay, so finally what you can do, you can easily find the value of a. So here what will be the value of a? You just subtract equation number 1, equation number 2. So you remove equation 2, from equation 2 you remove equation 1. Okay, from 2 you remove 1. So equation 2 minus equation 1, what you will get? Okay, what you are going to get? So that will be 130a is equal to, yes or no? 130a, is this correct? Is there any mistake? No, I think everything is correct, right? Okay, so 130a, that is equal to, I think we have done some mistake. What is the mistake? Anyone? Second equation. We have done some mistake in the second equation. See, it will be a n3 plus b n2. n3 is 1400. n3 is 1400. Right. Okay. So n4 is 18,000. So the n4, that is a n3 plus b n2. n2 is 100, 100b. And here the equation is also correct, right? So where is the mistake? So 1400. Oh, okay. This is okay. I wrote it. Okay. I wrote it 14,000. Okay, sorry. This will be 1400. Okay, so now these will cancel. Yes. Okay, so these will cancel. These will cancel. I made a mistake here. I wrote 14,000 here. So these will cancel. Now finally you can check. So now you can see that 4a, that will be equal to 40. So a will be 10. Okay, yes or no? So a is going to be 10, right? Okay, a will be 10. Is this clear? So very simple. A is going to be 10. Now what about the value of b? Now you can also calculate the value of b. So a is already 10. So the value of b will be 40. Yes or no? B value, that will be 40. So B value is 40, A value is 10. So finally A plus B, that will be 50. Okay, so you can see for this question the answer will be 50. This was a very simple question, right? Agree with me? Do you agree with me? This was a very simple question. Just make two equations. You can solve this question easily. So the answer will be 50. Just make two equations. Everything is very simple. Now let me tell you the method number 2. Let's see the method number 2. And this is a nice method, analytical method. Basically write recurrence relation directly. Yes or no? Basically write recurrence relation directly. Let's write recurrence relation directly. Okay, can you write the recurrence relation directly? See, the question is saying nk is equal to number of k length sequences. Number of valid sequences of k length. First of all, what is a valid sequence? You tell me. First of all, what is a valid sequence? See, the valid sequence is like this. The first character must be a digit and the last character must be a digit. Yes or no? The first character must be a digit. The last character must be a digit. This is already given to you. First and last character, they must be a digit. Okay. In between, if there is sign, see, if there is no sign, no problem. Okay. If there is a digit, no problem. If there is a sign, then it must be followed by a digit. Okay, if you have a sign, then it must be followed by a digit. You must put a digit here. Okay, if there is a sign, you must put a digit here. Here you can put digit or sign. Here either you can put digit or you can put sign. Is this clear? So no problem, you can put sign here because sign is followed by digit, or you can find digit. or you can put digit. So remember, here you can put a sign because sign is followed by digit, or you can put a digit, no problem. I hope you understood this. Okay, is this clear to everyone? Please tell me. So this is a valid sequence. Now let's write the recurrence relation. Let's write the recurrence relation. First of all, what is nk? Nk is basically number of valid sequences of length k. Okay, so what is nk? Notice, nk is basically number of these sequences. Please focus. Nk is number of these sequences where the first character is d1 digit and the last character is digit. Yes or no? So the nk is basically these sequences, this type of sequences. How many this type of sequences are there? This is your nk. Okay, so this is the pattern for nk. Please notice. This is the pattern. This pattern means how many this pattern you have, that is nk. Okay, how many this type of patterns you have, how many this type of patterns, that is nk. So what is nk? Nk is basically how many this type of patterns you have. Also remember, if there is a sign, it must be followed by a digit, that you already know. If there is a sign, that must be followed by a digit. Okay, so this type of pattern, how many this type of patterns you have? So that is your nk. Nk is number of such patterns, of length k. Okay, is this clear? Very simple. How many such patterns of length k you have? This is the idea. Okay, so remember nk, this is this type of patterns. How many this type of patterns you have? Remember, it is starting from digit, it is ending with digit. So how many this type of patterns you have? This is your nk. I hope you understood. Okay, now let's see how to write the recurrence relation. So very simple point. Let's write the recurrence relation. Now we are going to write recurrence relation. See, the recurrence relation is very nice. Okay, you can easily write this recurrence relation recursively. See, in an analytical way. So let's see how to do this. See, okay, let's look at this. You can see already there is a digit here that you already know, and there is a digit here that you already know. This is your nk, right? This is your nk. Okay, so now this, look at this second position. So this second position, either you can put digit or you can put a sign. Yes or no? See, for this second position, here either you can put a digit or you can put a sign. Agree? So here either I can put a sign or I can put a digit. Agree with me? Okay, so let's see. If I put a sign here, then what will happen? Okay, either you can put a sign. This is what I am saying, that either you can put a sign here, means this is digit. Let me put a sign. Let me put a sign here. Okay. Or what you can do? Or you can put a digit. Okay. Or what you can do? You can put a digit. So here you can put a digit. Now you tell me, if I am putting a sign, then what should be this? Just tell me this point. What should be this? Let me know. If I am putting a sign here, then what should be this value? I am asking, what should be this value? This must be a digit. Yes or no? This must be a digit. Okay. Agree with me? This must be a digit. This. Look at this and tell me, yes, this must be a digit. Right? Yes or no? So you must have a digit here. This must be a digit. Agree? So, and similarly you tell me, if this is already a digit, then there is no problem. Yes or no? There is no problem. So you can see that what I am telling you. So if you are putting a sign here, then it will be a digit. Then here you have to put a digit. Okay, you have to put a digit. Now you look at this. Tell me what is this value? How many patterns? How many these patterns are there? Can you tell me? How many these patterns are there which are starting from digit, ending with digit? Please notice. What was your nk? Focus on your nk. What was nk? Nk was length k starting with digit and ending with digit. Yes or no? This was your nk. Please notice, this was your this type of pattern. How many this type of patterns are there? Number of this type of patterns, that is your nk. Agree? Is this clear? How many this type of patterns are there? That is your nk. If you remember. So you tell me, I am asking, how many such patterns are there? How many such patterns are there? Starting with digit, ending with digit. How many such patterns are there? So that will be nk minus 2. Yes or no? Because you have length k minus 2. Here the length is k minus 2. Here the length is k minus 2. So how many these patterns you have? That is nk minus 2. Similarly, you tell me how many such patterns are there? What are the number of these patterns which are starting from digit, ending with digit? Because remember, what is nk? Nk is number of patterns which are starting with digit, ending with digit. So for example, what is n5? What is n5? N5 is this type of patterns which are starting with digit, ending with digit. Okay, yes or no? This is your n5. And if there is a sign in between, if there is a sign, then it must be followed by a digit. So these conditions, this condition is also there. So I hope you understood. This is your n5. Number of such patterns. Number of such patterns is your n5. So this is what I am asking, that how many such patterns are there? Can you tell me? Can you tell me how many such patterns are there? That will be nk minus 1. Yes or no? Which are starting from digit, ending with digit. So how many such patterns are there? Nk minus 1. So either this can happen or this can happen. Now you can solve this question easily. Now you can easily solve this. So tell me finally what you can say. So we are calculating nk, right? We want to calculate nk. But there are two situations possible. Either this pattern is possible, that here you have a digit, here you have a digit, and here you have a sign. If there is a sign here, then this will be nk. So this will be nk minus 2. Please understand. Number of these patterns will be nk minus 2. Okay. So what that will be? So here, what that will be? Let me know. So total how many these patterns are there? Total how many these patterns are there? That will be 10 into, here you have 10 ways. Okay, yes or no? Here you have 10 ways, and here you have 4 ways. Here you have 4 ways. So total that will be 40 nk minus 2. Is this clear? 40 nk minus 2. Or what is possible? Or this is possible. Or this is possible that first character is digit, last character is digit, and here also you are putting a digit. Here also you are putting a digit. Okay, now remember, this is your nk minus 1. Please understand. This one, from digit to digit, from digit to digit, from digit to digit. Okay, this is your nk minus 1, right? Yes or no? So very simple. This is nk minus 1. So tell me finally, how many are these? So here you have 10 ways. Okay, because there are 10 digits, so there are 10 ways. So this will be 10 nk minus 1. So your nk will be either this or this. Nk will be this or this, so that will be plus. So your nk, what your nk will be? Nk will be 10 into nk minus 1 plus 40 into nk minus 2. Is this clear? So this is your value of a. We are calling it a. In the question they are calling it a, and they are calling it b. They are calling it b. So you can see a plus b, that is basically 50. Okay. So this is how you can write the recurrence relation. I hope you understood this. Please tell me, did you understand this solution? So two methods we have seen to solve this question. The question is very easy. You can solve this question by method 1 or method 2. Okay. So either you can use method 1 or you can use method 2. So this is your question. Please tell me, did you understand this question? Let me know. Let me know, is this question clear to everyone? Please tell me. Let me know. Anyone has any doubt in this? Please tell me. Okay, did you understand both the methods? Method 1, method 2. Did you understand both the methods? You can use method 1 or you can use method 2. In the exam, you can use method 1, but understand method 2 also. Okay, method 2 is also very nice. Analytical method. How to write recurrence relation. That is what I have told you. Okay, let's move on now. Let's solve this question. This is very beautiful question from the DBMS. This is a beautiful question, let me tell you. The most beautiful question from the DBMS. This is question from Ullman book. Okay, let me tell you the source of this question. The source of this question is Ullman book. Ullman DBMS book. Okay, so this is a beautiful question for which detailed video solution I have already provided. You can see here. Okay, you can just check it out. Go to this question. Under this question, you can find this detailed video solution with many variations. See, you can find the detailed video solution with many more variations. In this video solution, I have provided the solution of this question. This question also we have done, and also some more variations I have done. So please watch this video. Let me tell you, this is a new type of question, and this is a very simple but very beautiful question from Ullman book. I am again telling you, this is from Ullman DBMS book. Ullman DBMS book. And this is a new type of question. In the GATE exam, in future they can ask you this. I guarantee. In future, someday they will ask you. Okay. Maybe in 2024, maybe 2025. Okay, maybe after 2 year, 3 year. But I can guarantee that some GATE exam will come. In future, some GATE exam will come when they will ask you this question. This question is for the future GATE exam. Okay, this is the, I can say this is NYQ. You can call it NYQ. This is next year's questions. Okay, this is a next year's question. Maybe not next year, but maybe future year. I can say this is FYQ. You can call it FYQ. Okay, next, or you can say future year question. This question will definitely come in the GATE exam in future years. Okay, because this is Ullman question, standard question from the Ullman book. So do watch the video solution. Detailed video solution I have already provided to you with many more variations. So, okay, watch it. And please comment. After watching this video solution, please comment. Okay, so please put a comment. Please give your feedback. Okay, so please put a comment and give your feedback. Okay, so please do that. Okay, let's move on now. Let's solve this question. Decidability question from theory of computation. Which of the following are undecidable? Some options are given to you. Okay, so basically all of them are properties of Turing machine, right? Yes or no? You can see M is a Turing machine, M is a Turing machine, M is a Turing machine. Oh, here you have M is a DFA. Okay, so these are language properties of Turing machines. Okay, so you can apply the Rice theorem here. The question is asking which is undecidable. Let's look at option A. You can apply the Rice theorem here. Option A is basically set of Turing machines, encoding of Turing machine. What this means? This means encoding of Turing machine. So basically set of strings where every string indicates a Turing machine. So M is a Turing machine such that LM is not equal to 5, LM is not empty, and LM is not sigma star. Okay, LM is not empty and LM is not sigma star. Tell me, is this trivial property, non-trivial property? What is this? Let me know. Please tell me. Look at this. See, this is a language property, right? Yes or no? M is a Turing machine that is already given to you. M is a Turing machine that is already given to you. So you tell me. Here this is a language property. Yes or no? This is the property of recursive enumerable languages. This is the property of language. This is the property of language of Turing machine. Yes or no? This is the property of language of Turing machine. So tell me, you can apply the Rice theorem. To solve this question, you can easily apply the Rice theorem. So you tell me, this property, look at this property. Can I say every RE language will satisfy this? Okay, this property, what is the property here? What is the language property here? Here the language property is not being equal to 5 and not being equal to, so LM is not 5 and LM is not a sigma star. So this is a language property. You tell me, is this trivial or non-trivial? This property, is this trivial or non-trivial property for RE languages? This is non-trivial property, right? Yes or no? This is the non-trivial property for RE languages. Property for RE languages, recursive enumerable languages. Okay, this is a non-trivial property. Remember, this is a non-trivial property. Why this is a non-trivial property? What are the reason this is a non-trivial property? This property, I can say, look at this property. This is non-trivial. This is non-trivial property for RE languages, for recursive enumerable languages. For recursive enumerable languages. Why? Because you can see some recursive enumerable language will satisfy this. For example, this property you can notice for some recursive enumerable language. For example, if I give you L equal to, let's assume some RE language I give you, let's assume A power n, B power n. Okay, if I give you this RE language, then for this the property is satisfied, yes or no? And for some language, if I give you this RE language, for example, if I give you this RE language, then this will not satisfy this property, right? Yes or no? So remember, some RE language will satisfy this property, some RE language will not satisfy this property. So this is a non-trivial property for RE languages. And because this is non-trivial property for RE languages, so that is the reason this option A, I can say this language is undecidable. This is not recursive. This language is undecidable. Is this clear? Very simple. What about monotonic, non-monotonic? Tell me, this property, is this monotonic or non-monotonic? In the option A, this is given to you set of Turing machines, set of encoding of Turing machines, where M is a Turing machine. Okay, and this property is given to you that Lm is not equal to phi and Lm is not equal to sigma star. And Lm is not equal to sigma star. Is this monotonic or non-monotonic? This is a non-trivial property because some RE language will satisfy this property. Like this is a RE language, this is a recursive enumerable language which will satisfy this property, and this is a RE language which will not satisfy this property. So this language is undecidable by Rice theorem. You tell me, is this monotonic property or non-monotonic property? What about the monotonic, non-monotonic property? Tell me. So you can see this property, this is a non-monotonic. Why? See, you can easily see this is non-monotonic. What is the reason? This property, look at this property. This is non-monotonic property. What is the reason? This is non-monotonic property of RE languages. Okay, why this is non-monotonic property of RE languages? Because you can see, for example, consider this RE language. I am giving you RE language which will satisfy this. Consider this RE language L1 which will satisfy this A power n, B power n. This will satisfy, yes or no? This will satisfy. Now you consider its superset RE. Now I am giving you its superset RE. Now I am giving you its superset RE, which is sigma star. I am giving you its superset. Yes or no? This is superset RE. But you can see this sigma star will not satisfy. This sigma star will not satisfy. So this property is non-monotonic because you can see this RE language will satisfy this property, but I am giving you its superset RE. This is a superset RE. This is a superset RE which will not satisfy this property. So this is a non-monotonic property. Because this is a non-monotonic property of RE languages, so this L is not RE. So this L is basically not RE. Is this clear? So this is undecidable, and also this is undecidable and unrecognizable. Is this clear? This is undecidable and unrecognizable. So did you understand this? Please tell me. This is non-monotonic property. What is the reason? Please notice, because I can give you RE language which will satisfy this property. This property is satisfied by this RE language. Now I can give you a superset RE I can give you which will not satisfy this property. This is superset RE I can give you which will not satisfy this property. So this is a non-monotonic property, and that is the reason this L is not RE. I hope you understood. But the question is only asking for decidable. The question is only asking for decidable. So that is the reason I can say yes, this is undecidable. Yes or no? Actually, this is not RE. Actually, this is not RE. But the question is only asking for decidable. The question is asking for undecidable. Yes, this is undecidable. Okay, this is actually undecidable because this is a non-trivial property. This property that is given to you, this property is a non-trivial property for RE languages. What about the option B? Lm equal to phi. This is also non-trivial. Okay, this is also non-trivial property. This property is also non-trivial property. But this is actually RE. Yes or no? Sorry, what about this? This is also not RE. This is non-monotonic property also. This is also not RE. Okay, and this is undecidable also. See, let's look at option B. Let me tell you what about option B. Option B is this language which is set of Turing machines, set of encoding of Turing machines. So this M is a Turing machine and this means encoding of Turing machines. So this is a string. Remember, this is a string because language is set of strings. Please notice, language is set of strings. Language cannot have Turing machine. This language cannot have Turing machine. This language has strings where every string denotes a Turing machine. Every string represents a Turing machine. So you can see this is a language which contains encoding of Turing machine. So here M is a Turing machine. Okay. And the question is saying that LM is equal to 5. So empty language. The language is empty. Now here what is the property? Here what is the property? The property is basically being empty. Being empty. Yes or no? Being empty. This is the property. Now being empty, this is the property. This is non-trivial property for RE languages. This is non-trivial property for RE languages. For recursive enumerable languages. Because remember, this is already given that M is a Turing machine. M is a Turing machine, so LM is recursive enumerable. Yes or no? M is a Turing machine. So this LM, this is recursive enumerable. So remember, this is non-trivial property for recursive enumerable languages. Okay. Also, this is non-monotonic. See, why this is non-trivial? First of all, you tell me. Why this is non-trivial? This is non-trivial property for RE languages. Why? Because I can give you a RE language which will satisfy this property. Like for example, this RE language will satisfy this property. I can give you another RE language which will not satisfy this property. For example, I can give you this RE language which will not satisfy this property. So that is the reason I can say this property, look at this property, this is a non-trivial property. Okay, this property, look at this, this is a non-trivial property. This is non-trivial for RE languages. For RE languages. Okay, so that is the reason this L will be undecidable. This L will be undecidable. Is this clear? What about monotonic, non-monotonic? So this is non-monotonic. Okay, this property, this is non-monotonic. Why this is non-monotonic? This property is non-monotonic. Why? Okay, what is the reason for non-monotonic? Because you can easily see, I can give you a RE language which will satisfy this property. Which will satisfy this property. I can also give you superset RE. I can give you superset of this. I can give you superset RE which will not satisfy this. Yes or no? I can give you a superset RE which will not satisfy this. So notice this property is a non-monotonic property. Why? Look at this property. This is non-monotonic because I can give you RE language like this RE language, this recursive enumerable language which will satisfy this property. This RE language will satisfy this property. And I can give you its superset which will not satisfy this property. Okay, I can give you a superset of this RE language which will not satisfy this property. So that is the reason this is non-monotonic property. Yes or no? And because this is non-monotonic property, so I can say this L, this becomes not RE. This becomes not RE. Okay, very simple. Now let's see what about the next one. Set of Turing machines where M is a Turing machine and LM is uncountable. Okay, let's look at option C. Option C is saying that this is the language you have. What language? Set of encoding of Turing machines where M is Turing machine, and we are saying LM. What is LM? LM is uncountable. LM is uncountable. Is this trivial or non-trivial? This property, is this trivial or non-trivial? Let me know. For RE languages, is this property trivial or non-trivial? Let me know. For RE languages, for recursive enumerable languages, this is trivial or non-trivial property? Please tell me. This is a trivial property because every RE language is countable. For every RE language, this property is not satisfied. For every RE language, this property is false. Yes or no? For each and every RE language, this property is false. So this is a trivial property for RE languages. So that is the reason L is decidable. Yes or no? Okay, please notice one thing. Very simple point I want to tell you, and that is, just tell me this question I am asking. Okay, let's assume I am giving you a language. This is a not RE language. This is a not RE language. I am giving you a not RE language. I am giving you. Okay, and I am giving you a RE language. Tell me which is countable, which is uncountable. Tell me which is countable, which is uncountable. Very simple question I am asking. Which is countable? Which is countable? Please tell me. Which of them is countable? L is not RE language and L1 is not RE language. L1 and L2 is RE language. Which of them is countable? Which of them is not countable? So the answer is both are countable. Yes or no? Both are countable. Every language is countable. Every language is subset of sigma star. Yes or no? Notice one thing. Please notice one thing. Every language, when I say every, it means every, RE or not RE. Please notice every language L is a subset of sigma star. Yes or no? Whether you take RE language or not RE language, every language is subset of sigma star. Whatever language you can take RE language, you can take not RE language, you can take any language you want. Every language is subset of sigma star. Okay, sigma star is countable. Sigma star is countable. Subset of countable set is countable. So every language is countable. Yes or no? Every language is countable set. Please notice, every language is countable set. But if I say X is set of not RE languages. Okay, X is a set of all not RE languages. X is a set of not RE languages. Okay, and Y is a set of RE languages. And Y is a set of RE languages. Now which is countable? Okay, please understand. X is set of not RE languages and Y is set of RE languages. Now which is countable? Now which is countable? Okay, X is a set of all not RE languages and Y is set of all RE languages. Now which is countable? Only Y. Only Y is countable. Yes or no? So please understand the difference between RE language and not RE language and set of not RE language. Please understand the difference. Please understand the difference. This difference you understand. What difference? First, a not RE language. If I say L is a not RE language, a particular not RE language. Okay. And another I am telling you X, which is set of all not RE languages. Which is set of all not RE languages. Okay. So please notice that every language is countable. This is countable. Every language is countable because every language is subset of sigma star. Sigma star is countable. Subset of countable is countable. So you can see every language is countable. But set of not RE languages, this is uncountable. This is uncountable. Okay, is this clear? So you can see here in this option C, we have set of encoding of Turing machines where the language of Turing machine is uncountable. This is trivial property. This is trivial property for RE languages. Why? Trivial property for RE languages. Why this is trivial property for RE languages? Because every RE language will dissatisfy this. Yes or no? Because I can say no RE language satisfies this. Because no RE language satisfies this. Satisfies this property. Because every RE language is basically countable. So no RE language will satisfy this. Yes or no? So that is the reason this is a trivial property. So this is decidable. Okay, option C is decidable. What about option D? Option D is saying that set of DFAs, encoding of DFA. Here M is DFA. Here M is DFA and you are saying that LM is countable. LM is countable. Again, this is a trivial property. Again, this is a trivial property for regular languages. Yes or no? See, this is a trivial property. Because every language is countable. Yes or no? This is a trivial property. And anything which is trivial is always decidable. Trivial property is always decidable. Okay. Trivial property is always decidable. You can take any trivial property. That trivial property will always be decidable. Is this clear? So because this is a trivial property, remember every language is countable. Whether you take not RE language or you take RE language, every language is subset of sigma star. Every language is countable. Okay, so here I can say this is decidable. These two are decidable. They are decidable. Okay, is this clear? So for this question, the question is asking what is undecidable. The answer will be option A, B. So this will be the answer. Is this clear? Please tell me. Let me know. A student is asking, sir, can you please explain once brief why sigma star is countable? Sigma star is countable because you can create a one-to-one mapping you can create a bijective mapping between set of natural number and sigma star. That I have already explained in the countability playlist. On the goclasses YouTube channel, you can find the countability playlist. Okay, countability complete playlist, countability complete course is freely available on the goclasses YouTube channel. Okay, just search on the YouTube, you search goclasses countability. Okay, then you will find a playlist that is complete course on countability, uncountability. What is countable, what is uncountable, what are the countable, uncountable results in theory of computation. So basically that is the complete playlist. Okay, in that playlist everything is explained. Every gate question, every TIFR question we have done in that playlist. Each and every gate and TIFR question we have solved. So you can watch that playlist. Every proof is given. Okay, that is a complete playlist for countability and uncountability. You can watch it. Is this clear? So you can just watch it. Or maybe you can comment. I will share the link. Okay. See, you want the proof why sigma star is countable. This is what you want to find out. Yes or no? So you can put a comment under this video. I will reply to that comment. I will put the exact video in which I have given the proof. Okay. The exact video in which I have given the proof that sigma star is countable. That video I will put in the comment. Okay. So please put a comment so to remind me. Okay. So thank you. Now, I hope you understood this question. Is this clear to everyone? This particular question? Let me know. Is this clear? Okay. Let's move on now. Now let's solve this question. This is a very simple question from finite automata. What the question is saying? Below you see the transition table of a finite automata, a finite state automaton. The initial state is 0. Okay, that is the initial state. The final state is 4. And what is this phi? Phi denotes the fail state. Okay, phi is the fail state where no successful transition is possible for any symbol. Okay, so remember phi is a fail state from which no successful transition is possible for any given symbol. Note that when encountering B in state 2, when you are in state 2, in this state 2, when you encounter this symbol B, when you see this symbol B, then either you can go to state 2, two transitions are possible. Either you can go to state 2 or you can move to state 3. Okay, so very simple point. Now, the question is saying which of the following regular expression matches the finite state automata? Which of the regular expression will represent the language which is accepted by this automata? Okay, this automata will accept a regular language. Now, which regular expression represents that language? The regular expression has to match exactly the same of the regular expression has to match exactly the same set of strings that are accepted by the finite automata, not more, not less. Okay, anyway, so let's solve this question. First, you can create a automata from this table. This transition table is given to you. Let me tell you what you do first. First, create NFA. First, draw NFA. Okay, first you draw NFA. So, let's draw the NFA. So, what will be the NFA here? This 0, this is the initial state. Now, the question is saying in 0, if you read symbol A, then you will go to state 1. Yes or no? In this state 0, this is the initial state and this is the final state. So, you can see in the state 0, if you read symbol A, you will go to state number 1. Okay, if you read symbol A, you will go to state number 1. Next, if you read symbol B, C, you will go to fail state. You will go to fail state where no successful transition is possible on any given symbol. So in NFA, you don't have to show it. Okay, in NFA, you don't have to show the this fail state. Yes or no? In the NFA, we don't have to draw the fail state. So there is no need to draw. Okay, there is no need to draw. Let's see this state number 1. In this state number 1, if you read symbol B, you will go to state number 2. If you read symbol B, you will go to state number 2. In this state number 2, if you read symbol B, you can go to state number 2 or you can go to state number 3. If you read symbol B, you can go to state number 2 or you can go to state number 3. If you read symbol B. Next, in state number 3, if you read symbol C, you will go to state number 4. Okay, here if you read symbol C, you can go to state number 4. Next, in state number 4, if you read symbol C, you will go to state number 3. Okay, if you read symbol C, you will go to state number 3 and this is your final state. Now you can create the regular expression very easily. So this is your initial state, this is your final state. What will be the regular expression? Very simple. The regular expression you can easily create, that will be A. First you should have A, then B should come, then any number of B can come. Yes or no? Then any number of B can come, B star. Then another B should come, then another B should come, right? Now you are here. Now you are here. Yes or no? Now where you are? Now you are here. Now what you can do? Now you are in this state. Now what you can do? Now you can do C, 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 C any number of times. Yes or no? This is C, C, you can do any number of times. C, 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 C. Finally, you will stay here. Yes or no? Agree with me? Agree with me? C. Please notice A. Please notice. First you do A. First you read A. Then you read B. Then you can read any number of B's. That is B star. Then you read another B. Now you are in state number 3. In the state number 3, you can read C, 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 C. Okay, like this. C, C. Then C, C. Then C, C. C, C. Like this. Okay, so you can easily see. You will stay here. So C, C whole star. Finally, if you want to go here, I want to go here, then you can read one more C. You can read one more C. So this will be your answer. Your answer is going to be this. A, B, B star B, C, C star C. So your answer will be A, B, B star B, C, C whole star C. This will be your answer. So let's see which option will match. A, B, you can call it B plus. B, B star, you can call it B plus, right? See, B star B, that is same as B, B star, that is same as B plus. So you can write it B plus. And this you can write C, remember, C, C, C whole star, you can write it C, C whole star C. Both are same, no problem. Okay, both are same. So you can put this C here, no problem. Okay, so you can see the answer will be option A. Option A is the correct answer. Option B is not correct answer because you can have any number of C. Yes or no? Actually, we must have odd number of C, right? Yes or no? Actually, we must have odd number of C. Notice here, A, C, notice here, A, B, then B plus, then you must have odd number of C here. Then you must have odd number of C. Yes or no? Odd number of C you must have. But you can see in option number B, you can have any number of C. So that is wrong. In option number C, you can have even number of C. That is also wrong. In option number D, you will have even number of C. That is also wrong. So I can say answer will be option A only. For this question, answer will be only option A. Okay, so this is a very simple question. I hope you understood. Is this clear to everyone? Please tell me. Let me know. Is this question clear? Let's move on. Let's solve this question. This is an interesting question, a very beautiful question. Okay, so let's see this. Which of the following statement about Turing machine is false? Some statements are given to you and we have to find out which statement is false. Okay, so let's see this. Which statement is false? For every context-free grammar. Okay, see what this is saying. For every context-sensitive language. Okay, so let's solve this question. Which of the following statements about Turing machines is false? Option number A, for every context-sensitive language, there is a Turing machine that will accept precisely the strings in the language. This statement is actually true, yes or no? This statement is actually true. Agree with me? Because every CSL is RE. Yes or no? Every CSL is RE. See option number A. Option number is saying that for every CSL, there is a Turing machine. Yeah, that is correct. Because every CSL is RE, you already know. Every context-sensitive language is recursive enumerable language. Okay, so this option is definitely true. This is true statement. The question is asking false statement. Okay, let's see the option number C. I will tell you what is option number B. I will tell you, but before that, let's see option number C. There is a Turing machine which, given encoding of 2 DFA over same alphabet, can tell whether or not they define the same language. Yes, this is also true. This statement is also true, right? Because see what this is saying. Option C is saying that given 2 DFAs, do they have same language? Okay, do they have same language? Basically, option C is saying that if I give you 2 DFAs, I give you DFA number 1, DFA number 2. I give you 2 DFA where D1, D2 are DFA, and they have same language. Okay, they have same language. See, this language you already know this is decidable. Yes or no? Equivalence of DFA. This is equivalence of DFA. This is equivalence problem. This is equivalence problem of RE languages. Agree? Yes or no? So this is the equivalence problem, of regular languages, because these are DFA. They are DFA. So this is equivalence problem of regular languages. Regular languages. Because D1, D2, they are DFA. So their language is regular. So LD1 is regular, LD2 is regular. Now this is basically, you have two DFA, given two DFA. Their language is same. Their language is same. This is equivalence problem of regular languages. And equivalence problem of regular languages, that is decidable. Yes or no? Equivalence problem of regular languages is decidable. What decidable means? Decidable means halting Turing machine exists. Yes or no? Decidable means halting Turing machine exists. So Turing machine also exists. Decidable means halting Turing machine exists. Because halting Turing machine exists, so Turing machine also exists. Turing machine also exists. Yes or no? Is this clear? See, read the option number C. Option number C is saying there is a Turing machine which can determine whether two DFAs have same language or not. Yes, this is correct, because equivalence of DFAs, or I can say equivalence of regular languages. If two DFAs are given to you, their language is same. This is basically equivalence problem of regular languages. Equivalence problem of regular languages is decidable. Decidable means halting Turing machine exists. For this problem, let's call it L. For this problem L, halting Turing machine exists. So for this problem L, Turing machine also exists, because every halting Turing machine is a Turing machine. So you can see, yes, there exists a Turing machine. Yes, there is a Turing machine which can which can decide whether two DFAs have the same language or not. So this statement is also true. There is a Turing machine which can simulate the behavior of any other Turing machine on any given finite input. This statement is also true. This is basically your universal Turing machine. Yes or no? This type of Turing machine is called universal Turing machine. Agree or not? So you can see there is a Turing machine which can run another Turing machine. Yes, that is correct. Okay, yes or no? Agree? So this is called universal Turing machine. This type of Turing machine is called universal Turing machine. This is a Turing machine which can run another Turing machine, which can simulate another Turing machine on any given input. So this is correct. This statement is also true. The question is asking false statement. These are true statement, A, C, D. So option B, that will be false. Option B will be false. But let's see what is option B. Option B is saying for any grammar. For any grammar. See what option B is saying. Option B is saying for any grammar. So tell me, when I say for any grammar, am I talking about regular grammar or context-free grammar or type 0 grammar? Tell me. In this option B, when I say for any grammar, I am saying for any grammar, any grammar. So am I talking about context-free grammar or context-sensitive grammar or for type 0 grammar? Tell me. Let me know. Yes, type 0 grammar. Yes or no? So very simple. For any grammar means for any type 0 grammar, there is a Turing machine that will accept precisely the strings not derived by this grammar. Okay, not derived by this grammar. This statement is false. This statement will be false. Why this statement is false? See what option B is saying. Please read option B. Option B is saying that for any grammar. So when I say grammar, that simply means type 0 grammar. Yes or no? By default, when we discuss about grammar, then this means no restriction. For any grammar means that is basically your type 0 grammar, or I can say RE grammar. Yes or no? Type 0 grammar means RE grammar. So for any RE grammar, the question is saying there exists a Turing machine which accepts its complement. For any grammar, there is a Turing machine which accepts its complement. See, notice one thing. What option B is saying? For any RE grammar G, there exists a Turing machine. There exists a Turing machine M which accepts LG complement. LG complement. This is the question. This is the option number B. Read the option number B carefully. For any grammar, whatever grammar I give you, there is a Turing machine that will accept which cannot be derived by grammar. So which cannot be derived by grammar, yes or no? Which cannot be derived by grammar, that is nothing but LG complement. Yes or no? Agree? That is nothing but LG complement. Cannot be derived by the grammar. Which cannot be derived by the grammar, that means LG complement. LG complement. So you can easily see the question is saying for any RE grammar, there exists a Turing machine which will accept LG complement. This statement is false. Why this is false? Basically, you are saying that, see, LG is RE, yes or no? See, notice one thing. For any RE grammar, LG will be RE. That you already know. For any grammar, whatever grammar you take, for any grammar, whatever grammar you take, when I say for any grammar, basically, you can take any type 0 grammar. You can take any grammar. Okay. Remember, every context-free grammar is type 0 grammar. Every type 1 grammar is type 0 grammar. Every type 2 grammar is type 0 grammar. Every type 3 grammar is type 0 grammar. So this will cover all the grammars. Notice, this will cover all the grammars. Type 0 grammars, these are all the grammars. So if I say set of all grammars, if I say set of all grammars, that is same as set of all type 0 grammars. Yes or no? This is same as set of all type 0 grammars. Type 0 grammars, which is RE grammars. Which is a RE grammar. Type 0 means RE grammar. Yes or no? Okay. So very simple. So you can see now for any grammar, whatever grammar G I give you, what will be LG? What will be LG? LG will be RE. Yes or no? LG will be RE language. Okay. LG will be RE language. Now the option B is basically saying that, for any RE language, basically for any RE language L, there exists a Turing machine which can accept L complement. There exists a Turing machine which accepts L complement. There exists a Turing machine which accepts L complement. Okay. So basically, there for any RE language, you are saying for any RE language, there exists a Turing machine which will accept L complement. Means for every RE language, complement is also RE. This is false, right? This is false. Why? Why this is false? Because basically option B, what basically option B is saying, let me tell you. Option B is basically saying that the complement of every RE language is RE. The complement of every RE language is RE. The complement of every RE language is RE. And this you already know this is false. Okay. This is already false. This is already false. Why this is false? Let me tell you why this is false. For example, consider this language. I am giving you this language L. Okay. Consider this language set of Turing machines where M is a Turing machine. Where M is a Turing machine and LM, I can say LM contains AB. Okay, look at this. LM contains AB. LM can contain something else also. Remember, LM contains AB. Okay, now you can see this language. Look at this language. This is RE but not REC. You can apply the Rice theorem. This is actually RE but not REC. Okay, this is RE but not REC. You can apply the Rice theorem, because this is the language property of Turing machine. So you can apply the Rice theorem. This will be RE but not REC. Okay, we are saying LM contains AB. Remember, LM can contain something else also. LM can contain AB, A, BB. Okay, so LM can contain, but at least this string must be there. Okay, there can be something else also. So you can see this language RE. You can apply the Rice theorem. This language RE. This is basically RE but not REC. Okay, now let me tell you that you already know the complement of RE but not REC. Like these are the RE languages. See, these are the RE languages and these are the recursive languages. These are the recursive languages. If you have some language here which is a RE but not REC, yes or no? This is basically RE but not REC. So if you have some language here, then its complement will definitely be not RE. Yes or no? Then its complement will definitely be not RE. If L is here, then L complement will definitely be not RE. Okay. So if L is here, then L complement will definitely be not RE. Is this clear? So you can easily see this language is RE but not REC, means for this language there is a grammar. Remember, there is a grammar. There is a grammar because this is language, this is RE language. This L is RE language. So there is a grammar, type 0 grammar. There is a grammar for L. There is a Turing machine for L. There is a grammar for L. But you can notice, but for L complement there is no Turing machine. Yes or no? But for L complement there is no Turing machine. There is no Turing machine because L complement is basically not RE. Because L complement is not RE. Is not RE. So I hope you understood. So this was a simple question, a very simple question, but this was a beautiful question. Okay, because some students they can get confused. Okay, because of confusion you can make a mistake. So remember option B, that is basically false. The question is asking which option is false. So the answer will be option B. The answer is going to be option B. Is this clear? So quite a easy question. I hope you understood this. Okay. So let's move on. Finally, let's solve this question. This is a push down automata question. So let's solve this also. Let's solve this question. Push down automata question. This is a simple question, you can see. Consider the following non-deterministic push down automata, NPDA. Okay. Consider the following NPDA, push down automata. The input alphabet is AB. The stake alphabet is star AB. The initial stake symbol is star. Acceptance is by empty stake. Okay, acceptance, that is by empty stake. That is the reason no final state is given to you. We use X as a variable that will range over the stake alphabet. Okay, so X is a variable that will range over the stake alphabet. So when you write like this, it simply means for every stake alphabet, X can be any stake alphabet. Means X can be star or X can be A or X can be B, because this is the stake alphabet. Because this is the stake alphabet. So you can see X. This X can range over stake alphabet. So this X can be star, this X can be A, this X can be B. So you can see X can be star, X can be A, X can be B. Okay. This PDA is given to you. The question is asking how many strings of length 12 are accepted by this PDA. This PDA will accept how many strings of length 12. So first you find out the language of this PDA. Yes or no? First you easily find out the language of this PDA. What this PDA is doing. Basically what this PDA is doing. Notice the initial bottom of the stake symbol is star. Okay. Remember initially what you have. Please notice initially on the stake what you have, that is star. Okay. Initially this is your stake. Initially on the stake there is star. Because the question is saying the initial stake symbol is star. This is the initial stake symbol. Okay. Now you can see the input alphabet is A, B. So if I give you some string, when that string will be accepted, notice when that string is going to be accepted. Notice what we are doing. See, this is a push state. Yes or no? This is a push state because you are pushing everything. Okay. Whatever top of the stake symbol is there. This X can be any top of the stake symbol. What is this X? X is basically any stake symbol. Any stake symbol. Any stake symbol. So remember, X can be any stake symbol. You are pushing A. Then you are pushing B. So remember, you are pushing A, you are pushing B. Okay. Then after some time, without reading the input tape, you are not reading the input tape, without reading any input tape, and without changing the stake, you are going to the pop state. You are going to the pop state. Yes or no? Without changing the stake, without reading the input tape. You are not reading the input tape. You are not reading the input. Also, you are not changing the stake. Okay, so you can see basically you are jumping to the pop state. Okay, from the push state, you are jumping to the pop state. In the pop state, what you are doing? On A, you are popping A. Okay, on B, you are popping B. And finally, at the end, you are popping star. Okay, because this will come at the end, yes or no? So you can see finally you are popping this star also. Okay, is this clear to everyone? So what is the language of this PDA? You can easily see basically the PDA is doing like this. That okay, that's till some point it will push. It is pushing A, B. If A is coming, A is pushing. If B is coming, B is pushing. Okay, at this point what you are doing after this point what you are doing, you are popping A on A and you are popping B on B. You are popping A on A, you are popping B on B until you see a star. Okay, until you see a star, then this star also you are popping so that you can get empty state, because acceptance is by empty state. Okay, acceptance is by empty state. Is this clear? So basically here what you are doing, tell me, this is basically your even palindromes. Yes or no? This is just a even palindrome language. See, if I give you this language where you have W belonging to A, B whole star, okay, W is even palindrome, is even length palindrome. W is even length palindrome. Now, you can see if you create the NPDF for this, then what is the idea? If you want to create PDF for this, PDF for L, what is the idea for that? Just tell me. Just let me know the idea. See, the idea will be like this, that you will use non-determinism. The idea will be you use non-determinism to find the middle. Okay, yes or no? You use non-determinism to find middle. To find middle symbol. Yes or no? Middle. To find the middle. So you can see basically some string is given to you. If I give you some string A, B, A, okay, A, B, A. Okay, then what you will do? You will use non-determinism. Remember, you are going to use non-determinism. So basically what you are going to do, okay, what you are going to do basically, you will push every symbol. Basically after every symbol you will think, maybe this is the middle. Okay, yes or no? Maybe this is the middle, maybe this is not the middle. Please notice, after every symbol you will think, you are thinking, maybe this is the middle or maybe this is not the middle. So either you will push. If it is not the middle, then you will push. If it is the middle, then you will pop. Yes or no? So after every symbol you are thinking, is this the middle? If this is not the middle, then I will push this, then push this. Okay, if this is the middle, then you pop. Okay, so yes or no? Very simple. So remember, basically, ultimately you will find the middle using non-determinism. You will find the middle, and then you are basically what you are doing. You are popping A on A, you are popping A on A, you are popping B on B, and you are popping A on A. So this is basically the PDA. Okay, you can see this is the PDA for even palindrome language. Let's create the PDA. Very simple. You will use non-determinism. Remember. So in the initial state, what you are going to do? In the initial state, this is the push state. In this state, I will push. Okay. So when you see the first symbol, what you will do? When you see the first symbol. So remember, as I told you, when you see the first symbol, so before every symbol, you are going to decide this. Means initially you are going to think. You are going to think, is this the middle or not? See, initially on the stack there is a star. This is the stack. Now what you are going to do? Before every symbol you are going to think, is this the middle or not? For example, is this empty string or not? Right? Yes or no? So you can see what I'm going to do. Okay. If you have empty string, if your string is empty string, on the stack, whatever you have, I don't care about it. On the stack, whatever you have, I don't care about it. Just go to the pop state. In the pop state, you can pop this star. Okay. See, the empty string case we will consider at the end. Now let's just see the simple case. For example, consider this case: A, B, A, B, B, A, B, A, A. Consider this string. So what you are going to do? Okay, if A comes, you will push it. Yes or no? You will push it. If B comes, so this A you will push. This A you are going to push. If B comes, that also you will push. Okay, if B comes, that you will push. This A you will push. This A you will push. Okay, yes or no? This B you will push. Then this A you will push. Then this B you will push. Okay, now remember, you will use non-determinism. You don't know what is the middle. You don't know. Maybe this is the middle. Maybe this is the middle. You don't know what is the middle. So what you will do? Without reading any symbol from the input, because you are checking even palindrome. So without reading any symbol from the input, this is your input. Without reading any symbol from this input, okay, without reading any symbol from this input, just go to the pop state. Because if this is the middle, then you have to start popping. Yes or no? If this is the middle, so you have to start popping. Agree with me? If this is the middle, so you have to start popping. So very simple point, very simple point. If this is the middle, so you have to start popping. So just go to the pop state. In the pop state, what you will do? If this is the middle, so in the pop state, what you will do? On B, you will pop B. Okay. On A, you will pop A. Yes or no? Now, at the end, what should happen? At the end, what should happen? At the end, this symbol you must encounter. In the stack, you must see this symbol. So at the end, input is ended. Now there is no more input. Input is already over. So because input is over, so without reading the input, this symbol you must see on the stack, then you pop it, because acceptance is by empty stack. Okay, already we are creating PDA with empty stack acceptance. With empty stack acceptance. Okay, so this is the same PDA that is given to you. In this question, the same PDA is given to you. Okay, basically, this PDA that is given to you, the language of this PDA, what that will be? The language will be even palindromes. The language will be even palindromes. Okay, now how many even palindromes of length 12 are there? How many even palindromes of length 12? Okay, so let's see length 12 even palindromes. Length 12 even length palindromes. Even length palindromes. So what that will be? Very simple. Because you are finding palindromes. Remember, you are finding palindromes. So only in the first 6 positions you have some freedom. Yes or no? You have freedom in first 6 positions. Okay, there is no freedom in the last positions. There is no freedom in the last positions, right? Okay, because see, whatever symbol you will put here, if I am putting A here, then automatically I have to put A here. See, there are 2 choices here. There are 2 choices here. We have 2 choices here. But once I put A here, then there is only 1 choice here. Then there is only 1 choice here, right? Correct. So similarly, you can see here also you have 2 choices. There are 2 choices, you can put A. But now there is only 1 choice. You have to put A. Now here also there are 2 choices. You can put anything. Here you can put anything. But once you put B, you must put B here. So there is 1 choice. So very simple. If I am putting A, you must put A. So for here, there are 2 choices. Either I can put A or B. But once I put A, then there is only 1 choice here. Similarly, here there are 2 choices. I can put A or I can put B. I can put A or I can put B. If I am putting A, then here there is only 1 choice. I have to put A. I have to put A. So like that. So basically, very simple. In the first 6 position, there are two choices. So I can say length 12 even palindromes. How many? That will be 2 power 6. That will be 64. That will be 64. This will be the answer. Answer will be 64. Those for this question, answer is going to be 64, which is a 2 power 6. Okay. I hope you understood. So this is enough for this session. We have done a lot of questions. We have done from All India Mock Test 2. Okay. So the remaining part 1, part 2 you can find in this playlist. This was All India Mock Test 2 Solutions Part 3. Yes or no? You can find this playlist. You can find Go Classes Test and Quizzes. Go Classes Test, Quizzes and Homework Discussion. This playlist you can find on the Go Classes YouTube channel. There you can find the part 1 and part 2. For example, you can see All India Mock Test 2 part 1, solution part 1, All India Mock Test 2 solution part 2. So part 1, part 2 you can find here. Okay, and this part 3 also is available here. You can see All India Mock Test 2 solution part 3. This we are discussing live. That is the reason here upcoming. Okay, so anyway, this is your part 3. So I hope you loved this test. Please tell me, did you learn something in this session? Let me know. And please comment and share your feedback. Okay, so please do that. Please put a comment and share your feedback. Did you love this session? Let me know. Did you learn something from this session? Please tell me. Did you learn something from this session? Please tell me. Let me know. So did you like this session? Please put a like. Please put the press the like button and please put a comment. Okay, please do that. So if you learn something new in this session, and if you like this session, if you loved the session, then please press the like button and please put a comment. Okay, please share your feedback. Please share your review. Please put a comment under the video. Okay. So thank you everyone. Some questions are remaining. some questions are still remaining. Many questions we have done, a lot of questions we have already done. Okay, I hope you loved the analysis of all the questions. I have provided you complete analysis of each and every question, yes or no? So there was no formality. I did not do any formality, right? Yes or no? For every question I have provided you detailed and complete analysis. For every question I have told you what is the most efficient method. For many questions I have given you multiple methods to solve the question. So this is the complete analysis of every question. I hope you loved the session. So please press the like button and please put a comment and share with all the GATE computer science aspirants. Okay, thank you so much. Thank you everyone. So some questions are remaining. Those questions we will solve in the next session. Okay.